Hello, everyone. Thank you guys for joining today's event. This is the AIAA Los Angeles University Student Branch Mini Conference 2025. My name is Ian Clavio, and I'll be the lead coordinator for this event. So, just to talk a lot about myself. I'm currently the Education Collegiate Chair for the AIAA Los Angeles section for the 24-25 term. This is actually my second term of being the Education Chair for the section. Currently the liaison for the AIAA Los Angeles section and AIAA student branches of Cal State Long Beach, UCLA, USC, and UNLV. Full-time, I am a structural analyst engineer at Northrop Grumman, providing integrated procurement technologies, stress assessments of engineering fabrication and assembly issues, and I coordinate with liaison engineers of Northrop Grumman to gather information of non-conforming material and high-quality dispositions to write a report summarizing the stress results and observations. All right, before I started Northrop Grumman, I was part of the AIAA Cal State Long Beach student branch chapter. You'll see me in the photo, just giving my usual talk about AIAA in a general body meeting, and then you'll see a couple of my friends here in a prior mini conference event, and also outreach. It's at a high school. Right, and during my time at AIAA, I was one of the main event coordinators for the 2021 Region 6 Student Conference. That conference was held virtually due to the fact that that's due to COVID-19 at the time. So you'll be able to see me and a couple of folks online. Yeah, and then just to briefly talk about the AIAA mini conference. So our last year's mini conference was held at Spin Lunch, and it was a great turnaround event. We were given the Spin Lunch tour and then the main facility at Spin Lunch, and you'll see last year's students that participated in the student conference. So in prior conferences in AIAA, we had some great conferences from a variety of venues. In the previous years, we once had a main conference at the S Cafe at Northrop Grumman, but majority of the time it was held at the library. And for the main purpose for the mini conference is to gather young professionals and college students together, just to get a networking opportunity and also meet some great people, especially for this year as we welcome some good AIAA HQ representatives, Lindsay Mitchell and AIAA CEO Clay Mowry. So whenever you have time, please network with everyone, especially Lindsay and Clay, as they're interested in meeting you guys, especially for the students.
The food.
Oh yeah, and then during lunch we'll be given the food in the back when the sandwiches come by.
Those are donut and coffee.
Yeah, and in the back we have a bottle of water and coffee if you guys are needed some refreshments. All right, so I know we started like a little bit late as everyone's come back for the Impulse Space Tour. So here I am giving out the introduction, and then I'll hand over the mic to Dr. Gary Lee, who will give the Impulse Race briefing. And then after Gary Lee, we'll have Clay Mowry and Lindsay Mitchell for the AIAA HQ presentation. And then we'll have our lunch. And then after lunch, the 4 student branches will present their presentations. And then after that, David from USC will talk about his Strato SOL design. And then Dr. Nahum Malamed will speak from Aerospace Corp. And then at 3 p.m., we will have an AIAA career panel where Dr. Ken Louis will be the moderator for this event. And then we'll end it off there. So a lot of good stuff coming up in today's event. Okay, so we'll start off with our first speaker, Dr. Gary Lee. He is the Director of Government Business and Development for Impulse Space. He is responsible for growing Impulse's in-space transportation business in civil and defense markets. Previously worked at Aerospace Corporation as a technical advisor for the United States Space Force, and he previously researched advanced propulsion systems at NASA JPL and Edwards AFRL. He received his PhD from UCLA in 2020, working on electric propulsion and nuclear fusion research, and his BA in astrophysics and physics from UC Berkeley in 2014. So is the presentation ready?
Yeah, connecting the Zoom.
All right, cool. Gary Lee will be connecting through Zoom, and then he'll be able to share his presentation from there. When your presentation is shared, I'll let you have the mic. Okay, you put it over here, and then. Let's see.
Oh, that's it. Yeah, you're right.
Am I allowed to share? If you can share right now.
There we go. There we go.
I need to.
Yeah, and then the folks here need to see a presentation from the projector. Or, let's see. All right, I think this is good. Or you want like,
There we go.
that works. That works. All right, take it away.
All right, thanks, Ian. Okay, well, good to see you guys again, and thanks Ken, Ian, and Clay for inviting me to speak and give you guys a tour of Impulse today. I'm super excited to be here. I try to be as involved as I can with young professional activity as well. I went to a lot of SGAC events, and I think I'm a member of AIAA, I should be. And I was also a Matthew Isaacowitz Fellow in 2019. So still try to be engaged where I can. Most of my time nowadays is spent at Impulse Space, where I work as the Director of Government Business Development. How's the camera angle? Where's the camera?
Oh, yeah.
Is this the camera?
You want to move around?
No, it's okay. I'll just
Yeah.
stare at this phone. Okay. So we gave you guys a tour of the factory today, but it's helpful to put in perspective and show you some pictures of what integrated capabilities look like, what are we actually marketing to the commercial and government markets, and also give you some time to ask some questions that you weren't able to ask on the tour. So without further ado, let's talk about the first slide here. And talk about our overall mission statement. If this wasn't mentioned during the conversation, the way we envision things is that we pick up where SpaceX drops off. And it's not only SpaceX, but there's a lot of other providers out there that are building launch vehicles that can deliver a lot of mass to low Earth orbit and to other centralized parking orbits. But what we do is doesn't look like, oh, thanks. What we do is we focus on the in-space architecture. So after we get dropped off by, say, the SpaceX Falcon 9, a transporter rideshare mission in a low Earth orbit, we build the FedEx truck or the Uber in space that then takes satellites the last mile to where they want to go. If you get dropped off by the SpaceX transporter, you're essentially stuck in this 550 kilometer sun synchronous orbit. And it's hard to get to these other orbits because you might have a CubeSat, especially a lot of the universities, you might have a CubeSat without propulsion, and you can't really maneuver to your final destination. But what we do is we put these small satellites on our delivery truck. We maneuver with the propulsion we build in-house and that you saw today, and then we drop you off at the custom orbit that you want to go to. And so that's the most fundamental description of how we operate as a commercial service. And we even build a bigger orbital transfer vehicle called Helios that you also saw, which basically takes that to the next level, right, and goes to these even larger orbits. And so back to a quick overview of the company, if there's anything you missed. We were founded in 2021 by Tom Mueller. Tom was the first employee at SpaceX, and he led their propulsion development for almost 20 years. He was the main player behind the Merlin engine, which is now the most successful rocket engine of all time, and that's what powers all the Falcon 9s that launch today. He also had a major role in all the other developments as well, including the Raptor engine, and he now has brought that over to Impulse Space, found in 2021 in his garage where he used to keep his sports cars. And now we replaced it with employees and spacecraft. So we were there for about 2 years or so in 6,000 square feet in El Segundo. And once we outgrew that space, we moved over to the new building, which you saw on Manhattan Beach Boulevard. That's 60,000 square feet. We've grown to over 60,000 square feet of vertically integrated manufacturing space, raised about $225 million in venture capital funding through a Series B round, and we've now successfully launched 2 spacecraft to orbit. The first one was designed, developed, tested, and flown in under 15 months, which for a refrigerator-sized spacecraft is quite a feat. There was a lot of tight schedules to make sure everything worked on time and was able to meet SpaceX's deadlines, and then to operate on orbit as well. And so after we've demonstrated that, we flew a second one just about a month ago, and we'll talk more about how that mission is going in a little bit. We talked a little bit about vertical integration today. So what does that really mean? When you vertically integrate, you bring capabilities in-house that you would normally procure from other providers. For example, when you try to repair your car, you typically go and buy some coolant or buy some engine oil from your local store and then bring it back and then do it when you're back at home, right? If you were to vertically integrate, then you would make the coolant yourself at home. You would mix some chemicals, in your bathtub and then pour it in your car. And in that way you can save on money. You save on the drive to the gas store, and then it allows you to control the manufacturing process quite a bit. And so in the space industry, this is especially powerful because companies like SpaceX have demonstrated that if you vertically integrate, you can control the cost and provide a very cost-effective launch service to the rest of the community. And you're also able to control the quality, the delivery schedule, and everything that makes the Falcon 9 such an attractive offering today. We are doing essentially the same thing for the spacecraft that we build, these orbital transfer vehicles. And so we do things like the 3D printing, which you saw. We have $1.3 million 3D printers that are workhorse for us in terms of prototyping new equipment and also building flight hardware that we now fly on our vehicles. We build a lot of the structures ourselves, a lot of the avionics components like the star trackers and reaction wheels. We do our own flight software and ground software, so we hire a team of software engineers to be able to do that all in-house. And the main thing we do is really the propulsion systems. Because of Tom's experience having done a lot of this at SpaceX and bringing over a lot of that key team, we build these small thrusters called SAFEs, 5 pounds, Rigel thrusters at about 180 pounds, and then the large Deneb engine, which you saw at the very end, that's about 15,000 pounds. These are all in-space engines optimized to perform in a vacuum. Very different than launch vehicle engines, but they're designed so that you can have as efficient of a high thrust performance as you can in space compared to other alternatives like maybe electric propulsion. And so we build a lot of this in-house. You've seen a lot of these images in person, so I won't belabor that. And I want to show you some of the vehicle itself, because you only saw components of this vehicle. Helios is this high energy kick stage that we've developed. We have a video we can show that shows you more of the concept of operations here. And this is available on our website as well. So imagine going up on a launch vehicle, getting dropped off in low Earth orbit. The fairing opens and Helios, along with a stack of payloads on top. You can see there's a sample satellite there. We get deployed from the launch vehicle. And then because we have this Deneb engine, we can fire this to go into a transfer orbit and say, go out to geosynchronous orbit. And then once you arrive and then do the insertion burn, you turn that off and then deploy your satellites into this target orbit. So this large, say, geocom satellite comes off, some smaller rideshare satellites come off, and at the end of life, we are all about sustainable space, and so we do a deorbit burn and go into a graveyard orbit for the final resting place. And so here's just some specifications if you're interested in that. Why is this kick stage valuable? Well, this kick stage is optimized to fit inside something like a Falcon 9 and other vehicles of that class. As you know, Falcon 9 is the most launch vehicle today. It launches almost every other day, over 100 times a year. And the main challenge there is that they can't do a direct to geo insertion. They can drop you off in LEO. They can deliver a ton of Starlink satellites there. And they can drop you off in a GTO, a geo transfer orbit. So that's the elliptical orbit that ends with the apogee at GEO. but it can't do the insertion. It can't insert you into the circular orbit that you want to be when you finally operate as a geocommunication satellite. And so what we have developed here is a kick stage, or quote unquote a third stage that goes on the two-stage Falcon 9 that can then do the restartable burns to go from LEO to GTO, a direct insertion into GEO where you drop off your customers, and then also the deorbit burn to dispose of it at the end of life. And so performance-wise, we can do about 4,000 kilograms direct to GEO. And that's very valuable because a lot of the geocommunication satellites, the really bus-shaped ones, if you go to a company like Boeing or Lockheed, you'll see these large $100 million, billion-dollar satellites that fill up an entire high bay, right? Our Helios kick stage was designed to carry some of these larger vehicles up there, and 4,000 kilograms is kind of that sweet spot where you can carry the majority of all those large buses up there. We can also deliver elsewhere as well. So in MEO, what do you have in medium Earth orbit? You have the GPS satellites. The Space Force is launching some missile tracking satellites up there. There's more activity in this area between LEO and GEO these days. And so we're also able to deliver there. But more importantly, and maybe what you might be interested in, is cislunar, lunar missions, deep space. We've been talking to NASA quite a bit about how we can use this kick stage to decrease the cost of accessing some of these higher energy orbits. And so imagine launching lunar landers on something like a Helios or a Mars lander, which is something we're developing in-house today, and hopefully some of you guys saw, or going around the moon, where Artemis and the Moon to Mars program is really excited about getting astronauts back to the surface of the moon. And so the rest of these are available on our website, or if you have any questions later. A little bit of orbital mechanics, since we do have a lot of engineering students here. We do a basic Hohmann transfer. Nothing fancy here. We don't do any fast transfers or weird things. We get dropped off in a geo orbit by the launch vehicle. And then once we're at the perigee, we do a transfer burn. So that's what that first arrow is. And then go into this elliptical orbit, this half ellipse. And then we do a final burn once we're out there, usually a little bit above geo. So it's a little safer. You don't kind of run into the billion-dollar satellites already parked there, right? That wouldn't be good. Insurance can't cover that. And then you drop them off before doing disposal burn to go into the final graveyard. We can also launch on other launch vehicles. So besides the Falcon 9, we can also launch on Terran-R, which is what Relativity Space is doing down in Long Beach. And we can carry slightly more payload on that one as well, up to 4,500 kilograms. What is the core piece of this technology? The kick stage is centered around this Deneb engine. And so we have about 15,000 pounds of thrust compared to the engines on our smaller spacecraft Mira, which I'll show later. Those engines are 5 pounds. So compare those small thrusters you saw, 5 pounds of force, to 15,000 pounds. That's a pretty big, large range in performance of what we can do in-house. And so this is an Oxbridge stage combustion cycle engine. We use liquid oxygen and liquid methane, so these do have to be cryogenically cooled, and they do boil off because they're so cold, and you lose propellant if you wait too long. And the majority of this vehicle is developed and assembled in-house. And so you saw a lot of those components today. This allows us to create a restart capable vehicle, so you don't just fire once and you're done. You can fire multiple times over the life of the vehicle and then do some more complicated concept of operations for missions you might want to do. We do have a test site. You weren't able to see that today, but we do have land rented out in the Mojave Desert. We built it, we basically rebuilt it from the ground up. It used to be just flat desert, right? Nothing on there but tortoises and other things. Now we have a fully assembled propellant supply facility. We have a data acquisition center. We've already done some initial igniter testing, which is firing the spark igniter in this engine, as well as doing a power pack test, which is flowing gas through a lot of the components like the turbo pump, but not doing the full hot fire of the entire stage. And so we're well into development testing today, and we're moving towards a first flight of our vehicle in the second quarter of 2026 for the Helios vehicle. And now, what is something, for those of you more interested in the economics of space, what is one thing that we're noticing today? Well, GEO isn't home to just billion-dollar communication satellites anymore. We're starting to open it up to a lot of smaller players. At the university level, you might be seeing a lot more CubeSats that you can build for under $100,000. The same thing is happening in the commercial space industry. We're going smaller, and that includes in these really high energy orbits like GEO. And so there's a lot of companies and government organizations today. I've just listed some of the market here. A lot of these companies want to go to GEO because it's a very unique orbit for doing different types of missions. And the main barrier to entry has been how expensive it is to get out there. Today, it can cost tens of thousands of dollars per kilogram to get out to GEO. To go to LEO, you can actually just look at SpaceX's website and look what the going rate is. It's about $6,000 per kilogram, going up to $6,500 per kilogram soon, to launch whatever you have to LEO. If you're trying to go to GEO, tens of thousands of dollars per kilogram. So a lot more expensive. And that is a barrier to entry to not only universities, but also to companies. And we're trying to drop that down by a few factors soon, and hopefully an order of magnitude over the long term when things like Starship starts becoming online. And so what we created, and this is public, we made an announcement at the Small Satellite Conference back in August of last year. We've created the first GEO rideshare program. If you're familiar with SpaceX's transporter missions, they've become a household name these days. Transporter basically lets you put together this Christmas tree of satellites, of small satellites, and get this low-cost access to space. This doesn't currently exist today for GEO. And so what we are doing is spinning up this new program that we call GEO Rideshare and putting together this Christmas tree of payloads on top of our Helios kick stage. It could be, CubeSat class, it could be Espa Grande class, which is these 300 kilogram class of payload. We want to be able to offer an affordable price for commercial companies and government to be able to start going there. Lost the slide here. I guess one thing interesting I didn't mention is kind of like career trajectory here. I studied engineering in grad school, physics for undergrad, so I was a technical person. But after graduating, I did decide to branch out a little bit and go into trying to figure out what the government is doing, because who knows what the government is doing, right? And then going into the business side. So business development, if you're not familiar, that's a fancy word for sales. So I'm a sales guy, not Wolf of Wall Street or anything like that, but more technical sales where you have to really understand your product and know what things like delta V means and know what a reaction wheel is. It's a really interesting career trajectory for majority of people that are engineers, but you get to understand how space as a business really works. And you get to talk to really cool people, also excited about building businesses across the world. We talk to like other international government agencies like Japan, NASA, Europe, ESA. We talk to international startups. It's a super exciting place to be. And so it's an opportunity you guys should potentially explore if you're an engineer now is, once you've mastered the engineering, is looking at how the business works, right? How do you create a product that not only is super cool and does cool things, but also closes the economic cycle, right? How do you actually make money as a business? It's a really exciting place to be, and I've been here for about 2 years. And now we're back to the technology, so let's keep going. Switching gears here, so the first product we talked about is Helios, which is this large kick stage. The second one is Mira, which is our Espa Grande refrigerator-sized orbital transfer vehicle. The one you see here in the image is this we'll call the second block upgrade of this, Mira V2. You can see the thrusters firing on there, some example payloads on the deck, those deployed solar arrays. There's something you couldn't really see in person today because we're on our way to launching the second version in the fall of this year. And so what I'll talk about in the next 2 slides is our first 2 successful missions. The first one's called Leo Express 1. It has a different shape. You can see in the top right there, it has a fixed solar array panel at the top, and then a chassis that kind of comes down to look like a top hat. The 2 circles in the middle, those are the COPVs, the propellant tanks, composite overwrap pressure vessels. We build our satellite around the propulsion system to have as much fuel as possible, so you can maneuver as far as you can for the different customers. On the left side, you can see the CubeSat deployer. And so that's where you basically put 1, 3U, 6U, 12U CubeSats into a spring-loaded deployer, so that once you get into space and you kind of maneuver into place, you can then spit them out on springs and have them go into their operational orbit. And so we are happy to say that on this first mission, even though we did all of this in 15 months, which we believe is a record for spacecraft of this class, we designed a lot of this in-house, right? Like we wrote the flight software, we built the flight computer boards, we built the thrusters and tested all of them. And so it was a big challenge to make sure everything closes and aligned to this very tight launch schedule. Otherwise, SpaceX just doesn't let you go up. You're like, they're gonna launch a brick instead of you if you don't come on time. And so it's tight consequences here. One of the most exciting things we did was we did deploy a CubeSat for another customer. So we did prove out the end-to-end value chain of going up, moving around a little bit, and then spitting them out. And so that's what we're hoping to do for constellations of CubeSats in the future. So imagine if you're now just not dropping off one, but you put, let's say, 8 16U CubeSats on our satellite, right? Each of them doesn't want to go to the same place. You want to deploy in a plane around the Earth, and then maybe have global coverage for Earth observation, right? That is the true value proposition of what an orbitable transfer vehicle like Mira can do. It hasn't been done to date. No one has done this because it's hard to build a spacecraft like this, right? Propulsion in space is really hard. And so we've been lucky to be one of the more successful programs, commercial companies doing this so far. And we're hoping that we can demonstrate a full constellation deployment sometime in the near future. The second mission is also very exciting. We launched this one just about a month ago in January. The first mission we operated for over a year on orbit before decommissioning it to put it in an FCC compliant orbit. So that means that it'll deorbit itself naturally due to drag in less than 5 years. That's really important because if you want to decrease the space debris in space, you have to make sure that when you're done with it, you don't just drop it where the space station is or something, right? You don't want to have that impact things at 10 kilometers per second. So we decommissioned that. We launched the Leo Express 2 just a month ago. We're happy to say that all systems are nominal today. We checked out the power system, made sure that we're power positive. We made sure we're pointing correctly so that we can get power from the sun, but also be able to point our payloads where they want to be pointed. We took a picture up there. That is a space selfie, by the way. If you read the license plate, it says, "How's my orbital maneuvering? Go to impulse.space." Aliens can see that too. So we're really excited to be able to take these crisp images and also prove that when we're deploying CubeSats, like the customers that want to go out, that they can actually see their satellite going out, right? Because sometimes you could say like, "Oh yeah, we deployed your satellite," but if there's no pictures, like, where's the proof? You got to capture in 4K. This was not 4K. This was a little lower resolution, but we were very successful in deploying 2 commercial customers from SatRev and FOSSA from that dispenser. And then we also have a few hosted payloads on board. So we have a space domain awareness telescope from a company called Hero Robotics. It's basically a telescope that you put on and then you point as you fly by things and then take pictures of them for things like space domain awareness. So Hero Robotics is an awesome company. Shout out to them. They take pictures of like the space station when we pass by them in LEO and other things. We're in the process of commissioning now, and they've already got first light on their sensor and have already getting their first images. And so that's our second mission. Still a lot of exciting things to do and big burns to complete. And here's a video of what that looks like. So Mira is, as you can see, it's a refrigerator-sized satellite. It comes off from this rideshare ring on our Helios vehicle, for example. Once you get deployed, what happens? So this continues from the last one. You deploy those solar arrays, you gimbal them. We have 1-axis gimbals to get power. We use cold gas thrusters to kind of orient and point. And then we have the primary safe thrusters that do these burns for the large translational burns. So if you're trying to like do a Hohmann transfer, you use these larger thrusters. And then this is an example of separating some free-flying payloads out there. You sprout your wings, and then you go do your thing in GEO. We also do missions for government customers. And so here's an example of, let's say, a shady object in GEO. It's passing by. We have a camera on board, and then we orient and take pictures of this vehicle. Because we are such a maneuverable vehicle, we can go down and, find other vehicles. We can move around the geobelt or in LEO. You just stick a camera on there, and now it's a very capable military asset, right? We are partnered with a few strategic players in this area. We are on contract with a few different government agencies to do these missions. One of the most, probably the most popular one that you might know about is the Victus missions. There's a mission called Victus Nox, which was launched on a Firefly vehicle with a Millennium bus, where they launched and deployed a payload on demand within 24 hours, basically simulate, if an adversarial nation launched a threat that you have no eyes on, you launch something up to go look at it as soon as you can, right? Inspect and characterize it. Well, we're doing a similar type of mission that's in responsive space, but it's called Victus Sergo and Victus Salo. And so what we're doing is we're launching our Mira bus. The Mira bus here, we're putting some sensors on there provided by the government. And then we're actually going to do flyby imaging of sensitive targets in both LEO and GEO. So instead of launching on demand, what we're doing is we're pre-positioning assets up there. Because what's faster than launching something and then sending it there? It's having it already there in the first place, right? So if there's a country up there that says, say, launches something suspicious into a low Earth orbit, but we have a constellation of these flying around, and then we can kind of fly by and then inspect the satellite within like a few hours, right? How powerful is that comparing to having to launch an entire rocket to space? And so that's the concept of Victus, Sergo, and Salo missions. You can look on the news for that. The details are obviously a little more sensitive, but what you can see from Impulse as a company is that not only are we providing these commercial like FedEx services of transportation, but we're also serving our country and working on these national security space missions, leveraging the fact that we build these really maneuverable spacecraft buses to go and tackle some of these challenging problems. In terms of performance, for the spacecraft nerds out there, I'll shout out some of these things. We are an Espa Grande class payload, so the bus itself is ballpark 300 kilograms. We can carry up to 300 kilograms of payload. If you max out at a 300 kilogram payload, we do about 500 meters per second of delta V. So that's basically a measure of how much fuel you have to basically move around between orbits. If you make that lighter due to the rocket equation, if you put a 100 kilogram payload on there, you can now do 900 meters per second. So that's quite a bit of maneuverability for this class of payload. If you look at our competitors out there, there's no one that can really offer this much delta V with the chemical high thrust propulsion that we build in-house. Using ethane and nitrous oxide for the propellants. So these are sometimes called green propellants out there. It's a buzzword, but what that means is you don't have to put on those bunny suits that you often see people wear to handle these things. They don't like burn your skin and give you cancer when you accidentally inhale it. Nitrous oxide is laughing gas. You can find that in your dentist's office, or you can see nitrous for like racing cars, right? Very easy to handle. And an ethane is also similarly a very, easy to handle type of propellant. And so that allows you to do things a lot quicker and a lot more safer than alternatives like hydrazine, which is a propellant some of you guys might be more familiar with. And so the last slide I want to end off here before I'll take any questions is really a vision of where Impulse Space wants to go as a whole. So broadly speaking, we are a company that focuses on in-space transportation. And so we want to do in-space transportation not just around the Earth, but to the rest of the solar system and maybe the galaxy one day, right? Who knows how far we'll go. There's a lot of things you can do around Earth with a very maneuverable vehicle. You can do this in-space transportation type of business. You might be able to work with space stations. You could do on-orbit refueling, on-orbit services. These are all things we don't do today, but that the market is really starting to look towards. And you're seeing a lot of startups pop up that focus on on-orbit refueling, like Orbit Fab, for example. Northrop is doing some of that. Space station logistics, you have all these companies like VAST, who Impulse is working with to launch a commercial space station to replace ISS after its end of life. There's so much activity in the near Earth sphere, and Impulse is really excited to get involved in more and more of that as we grow. Beyond the Earth, the new administration has been very excited about especially Mars, doing transportation to Mars. And as you saw, we are building a Mars lander. And so we would like to get that going in the next few years. And the moon as well, which there already has been new activity recently. There's commercial lunar landers now going to the surface, some that have been pretty successful. Firefly is actually in space right now, and they're about to do their landing in the next week or two. So tune into that if you haven't seen it. We are also building a Mars lander, and so you can imagine, there's a lot of things we could also do in these other areas. So as a company, Impulse Space is still growing. We're 200 people. We're not as large as many of these other companies out there. We've been around for 3.5 years, but we have very large ambitions, and with strong leadership at the helm, we want to be able to grow and do a lot more exciting things. And so very excited. If you guys are interested in Impulse, feel free to reach out to me if you have any questions. I put my email up here. We have a lot of job postings on the website right now, so feel free to put in some applications. But yeah, very excited to be talking to you guys here today, and happy to take any questions in the time we have left.
What sort of timeline can you put on that vision that you showed there?
There are some proprietary timelines there, but in general, if we were to talk about, we're talking about the near Earth stuff, this is all in the next few years, right? It's a little easier to get things to low Earth orbit. For the moon and Mars, I'll leave that up to the imagination. A lot of that is driven by government forces, unfortunately, and so let's see how fast the government moves. Other questions?
What are the consequences if you do not meet the deadlines?
For what kind of mission?
Just any in general.
Let's talk about the SpaceX missions. So if you go online to their website, they have quite a bit of documentation that's publicly available. So they have a rideshare users guide, which is what universities can access as well. It tells you the timeline of when you need to deliver certain things by when, because SpaceX is responsible for making sure that their integrated stack of payloads, including your smaller vehicles, doesn't blow up right on the way up, right? You need to make sure that the propellants don't leak, that you can survive the launch loads as you go up and other things. And so they have to make sure that you know what you're doing and to have verified it before you go. And so the timelines, they can start, they really start around launch minus 9 or 8 months or so. Around then is when the real deliverables are kind of due. But usually you sign up for a launch, you try to sign up for a launch like a year in advance or so. It's like you want to give yourself enough time, right, to make sure you build your satellite. And then you can also deliver the things you need to launch provider like SpaceX or Relativity or Rocket Lab. You need to give them what they need to make sure everybody else is safe. So if you don't make it on time, which is your question, a lot of times you have what's known as a mass substitute or a dummy mass. So you need to launch something up, because if you don't show up, if you don't drop off your CubeSat at L-3 or 4 months, whatever it is, right? If you don't give your spacecraft to the launch provider, they've already done all this analysis with a stack that has your mass attached to their interface, right? If you suddenly remove that, then now all your analysis, your Craig-Bampton analysis, which is the dynamics analysis you run for this, all of that is invalid, and now you don't know if you're going to launch successfully. So in order to prevent that, you now put a dummy mass, basically the same structural properties, right, for the dynamics, that literally doesn't do anything. It's like a dummy mass. You put it there, and then that takes your place as you go up. So the consequences for you is that you might lose your slot and you have lost your deposit and money on this kind of thing. But the consequence for the launch provider is now they're launching something that doesn't do anything. Good question. Any other questions? Sure.
This is kind of a personal question, but it seems that you are a very athletic man. How do you balance your personal life, since you have been to graduate school and it's a lot of work, and you also go to a lot of meetings and work?
Yeah, work-life balance. That's that's always the big question, right? At a startup, there's a lot more work. There is more deadlines, but the good thing is that they're usually very exciting deadlines, right? If you join a startup like this, typically you are excited about the company you signed up for, and that when you have something like a first launch coming up, right, you feel happy to work a little extra and get that thing going, right? I think I'm lucky to be at a company like Impulse where I'm just so attracted to the mission and so invested in it. I mean, to be fair, I did drink the Kool-Aid, right? But this is Kool-Aid I want to drink. And it's been very easy to, work a little more than I need to make that happen. But at the same time, you want to be careful about the company that you do join, because there are some companies that might force you to work overtime, right? Where you don't voluntarily kind of do it. And Impulse Space is one of those companies where we can kind of choose our ownership of what we work and how much time you need to do to get it done. Because we have this concept called responsible engineers, which comes from SpaceX, where you own a system, right? And me as a non-engineer now, like a business person, I own like a deal with the government, right? And you are responsible. I am responsible for making sure a deal gets done. If I decide, oh, it's clock has checked out at 5 o'clock, but this proposal is due tomorrow and it's not done, it's like, I want that contract to be signed. And so I will put in the extra hours and I'll be happy to do it. And then when we sign the contract, it is like the most exciting thing in the world. And so I think the trick for me throughout grad school, where, I did a PhD at UCLA, spent 6 years there. That was a long time and there were a lot of long hours done, right? I did the PhD willingly and I was very excited about the topics I worked on. I think the trick here throughout your career is to find something you are excited about and where you also have your expectations set for what you're getting into, right? When you interview for a job or for a grad school position, you should ask the lab or the company, like, what is the work culture like here? How much do you work? Are you given a choice in how much you work, right? Like, how much responsibility are you given? So when you're getting into that situation, you know that if you're going to work a lot of hours, you are making that choice to do it. And ideally, you are excited to make that decision. But there are also companies out there where you might be able to push the balance in the other direction, right? Maybe it's a bigger company where there's a lot more people that can cover your role. And 40 hours a week, or you get 980 or 410s, right? You get every other Friday off. I used to work at another company that did have 980s, and that was amazing for work-life balance, right? But what I did notice was that the pace was a little slower than I wanted. I wanted to go to a startup company that was pushing the boundaries of what you can do in the industry, right? Commercial works really, really fast. And that's why the government is so keen to have commercial do more and more of what the government traditionally did. And so I've been super excited about commercial space. I made the decisions knowing what the culture I was getting into was. And I do work extra sometimes, but I'm really excited to do it. And hopefully you guys can all make that educated decision yourselves and wherever you go. Time? Okay, thanks, Ian. So thanks for having me here. If you have any other questions, feel free to email me, but I'm really excited to talk to you guys. I do have to bounce afterwards, but I'm here in Redondo, always happy to answer whatever you guys got.
All right, thank you for coming to this great event, Gary. Before you leave, we have a couple of certificates to give you.
Awesome. Can I shake hands or something?
Hold it, and then you can shake hands.
Cool.
Thank you.
Thank you.
Thank you. Another round of applause for Gary. All right. We're then going to move forward to the next speakers. So we have Lindsay Mitchell and AIAA CEO Clay Mowry.
So hi everyone. I'm going to introduce Clay in just a second, but I just wanted to thank the section for hosting this event. I know they've done it for a couple of years now, and it's so important that students like you attend events like this and get to hear from people like Gary and professionals in the area so that you can get a better idea of what the industry is like after you graduate. And I'm sure a lot of you are taking time out of class or projects today. So again, just thank you for being here. We do have a lot of swag over on that table and some information about our AIAA programs. AIAA is so much more other than what you have at your student bridge. I'm sure you're doing lots of awesome, amazing things, but we have things like scholarships and mentoring and our Rising Leaders program, DBF, which I know many of you are working on in our regional student conferences. So I definitely encourage you to check out some of our materials that we have. Come find me or Clay after or later today. We'd be happy to talk with you more about that. And for our graduating seniors here, we actually have some graduation stoles for purchase. So if you're interested in getting one and repping that at graduation in a couple months, just let us know. So with that, I'm going to go ahead and introduce Clay, who can talk more about AIAA and kind of the what's to come with his leadership. So he is our CEO and globally recognized space industry executive. He's a lifetime AIAA member and was elected as an AIAA fellow in 2024. Clay's career spanned the commercial launch and satellite sectors as a senior executive for leading space companies and trade associations. Clay also serves as president of the International Astronautical Federation, or IAF for short. And this semester, he is actually teaching a class in rocket economics at Georgetown University in DC. So with that, Clay, take it away.
Thank you, Lindsay. And I think it's funny actually talking with the microphone. It's not that big of a crowd. Okay, I'll use the mic.
It's for the online.
For the online, okay. It's really a pleasure to be here, and it's really exciting for me to get back to Los Angeles and be with the section out here and meet so many folks from the branches. I've only been in this job for 145 days so far. Not that I'm counting the days, but yeah, I'm kind of counting it. So I really came in with one of these 100-day plans. I was trying to transform the organization, really re-energize AIAA. It's an amazing organization. I've been a member my entire career. And it's been near and dear to my heart. I was talking with Gary a little bit after the tour about why do I make this shift. I was in sales and BD, like he was talking about, for over 20 years, for about 25 years, selling rocket launches basically. And that's an interesting job. It's a fascinating job. You do have to know a lot about delta V and volume and mass and orbits and where things are going. But I also, during that whole course of that time, like Gary, I gave back. I joined boards. I was involved with a lot of different nonprofit organizations during the course of my career. And when this opportunity came up to lead AIAA, I jumped at the chance. It's really a great fit for me, having been on 8 or 9 different boards. I like to give back. I like to work with students, and I really like to work with the industry that I've been a part of for over 30 years. So with that, look, I made my first trip to Los Angeles, California. I'm from the East Coast, grew up in upstate New York. And I made my first trip to LA back in 1992 when I was working for the U.S. Department of Commerce in the Office of Aerospace. And I went to see McDonnell Douglas back in the day, which was in Huntington Beach, California. And they built Delta II rockets, which was one of the most reliable rockets on the market at that point. I got to tour the facility, meet all the folks there, and give a talk. And I had a Delta II poster hanging in my office for, about the first decade of my career in aerospace. That ended up becoming part of Boeing and then becoming part of ULA. And anyways, so that was my first trip ever. But I will tell you that when I look at the aerospace industry back 30 years ago and today, that this is the most exciting time in aerospace. The future is now. I'm jealous of you guys to be able to start at this point, because when I was starting this career, in my career in space, we weren't thinking about reusable rockets. We weren't thinking about air mobility and autonomy and systems and small satellites, the things that we were describing, be able to do these orbits and insertions and small satellites that you could actually start a company without having to raise a couple $100 million to put a satellite into orbit and buy the launch and put the spacecraft on. Now the barriers to entry are way lower. It's a lot more fun. There's a ton of private capital that's been pouring into this sector. You'll see different estimates about how much investment's being made in the space and aviation right now. But there's Morgan Stanley and other reports out there. They say it's $1 billion space economy now. Some have estimated a $50 billion a year industry. So there's a lot going on. So you guys are in the right field at the right time, is what I'm telling you. This is the super fun time to be involved. And I agree with Gary that you can take what you know in engineering, and there's a lot of directions you can go in this field, not just to be a program manager someday at a company, but also think about sales and business aspects of what you do as well. It's nice to be here with the sections. I've been making a point of getting out and meeting the student branches in the different sections around the country. So in my first 140 days, I've already made trips out to Colorado, and I got to meet with the Colorado School of Mines folks out there, the Ore Diggers, as that turned out, this is their mascot. I went to go see University of Colorado Buffaloes. Met some folks from Front Range Community College and Colorado State University when I was out there. I also got up to Boston recently and met the MIT engineers, who are the Beavers, is their mascot. So really good to meet those student branches, to get to meet students like yourselves, understand why you get involved in AIAA, what you do as student leaders in branches. And so I know we have some student branch leaders. Can you raise your hand if you're a student branch leader? One, couple, there. So I do want to meet with you guys and talk to you, get a little bit of why you're doing what you do, what's fun about it, get some feedback. We're trying to re-energize a lot and grow a lot. And Lindsay's actually doing a fantastic job. We just took on a whole bunch of new student branches, stood up, I think it's 6 internationally. What were the countries? Indonesia, Luxembourg, what am I missing? Bangladesh, yeah. So a lot of growth there. And the Southern Illinois, University of Southern Illinois, the Salukis are now members of our student family. We have 248, and I'm trying to get Georgetown to apply, so we maybe 249 pretty soon. But we're doing a great job growing all the student branches. We have roughly, out of the 30,000 members of AIAA, about 9,000 students that are involved in the organization. I want to grow that number by another 10 to 15,000 is my goal in the next couple of years. So watch that space, and we'll see where we can go. So I guess today we have what, UCLA Bruins are in the room. Any Bruins? A couple of Bruins. USC Trojans. All right, we got some Trojans. UC Long Beach. It's the beach, right? Is it the beach? Yeah, it's the beach. I had to look that one up. I didn't know that one. But I like that. What's with there's a dirt bags? What is that? That's the baseball team? All right. I'll tell me later why that is the name. And we got Rebels. Do we have any UNLV Rebels?
We were told that from Christian, who is the AIAA chair. Their car got out of like a flat tire, so they probably won't be able to make it. But I asked them if they can join online.
Okay, fantastic. I'm glad that they're joining us. Welcome Rebels online.
There's some USC student online.
Okay, fantastic. And then I guess we're doing the regional student conferences coming up, and that's going to be hosted by UC Irvine. Is that right? Anteaters. That's a good one. Anteaters is a really good one. It's almost as good as Salukis. So a lot of stuff going on with our students, and by the way, we're working on, if you go to DBF, and I hope a lot of you guys are going to go to the Design Build Fly competition that we do. And I give this advice to all the students that I ever talked to through my careers. If you can go to those kind of competitions, whether it's a rocket competition or DBF, that is something in the companies that I've worked with, like Blue Origin, we always look for that on your resume. If you worked in a team that you try to problem solve, figure out how to work together as a team, and put something that flies or launches or whatever, that's great stuff. And we look for that on resumes, in addition to the other stuff, your GPA and other things like that. So encourage there. At DBF this year, we're going to be rolling some stuff out. You're going to see some new AIAA logos, some new swag. We're going to get bomber jackets. It's going to be a super fun event. So I'm going. I'm going to go to Space Symposium, Colorado Springs, fly home, and then fly back out and be out there for DBF. So I encourage all you guys to go. Hey, look, also, Lindsay pointed to our swag over here. If you haven't gotten a stole for graduation, if you're graduating this year, please see Lindsay. We'll get you a nice AIAA stole for when you graduate. And you might have some other ones, but it's the coolest one, I think, right, Lindsay? It'll be the coolest. We've got a ton of events coming up this year. So, in fact, I'm going next week to Texas for AscendX, which is one of our space events. We hold it with the Johnson Space Center. We're going to be down there, and that'll be fantastic. I think we got 400 or 500 people registered already for that event. And then as we move forward this spring, we have 6 different regional student conferences that are taking place. One in Montreal. I'm going to be going to North Carolina, to Greensboro, but we have them here in California and other parts of the country. There's one in Texas, I think, that's being put on by our chapter, our branch in Dallas-Fort Worth area. So a lot going on. And then we will have Ascend Las Vegas this summer. So Ascend is our big space conference. If you're really interested in the space side of what we do in aerospace, then that could be one for you to come to. And I'll just back up a little bit, which is we already had our big SciTech event this year. SciTech we hosted in Orlando. It's usually the first or second week of the year. It's a great place to present your first paper. If you haven't presented a paper before, I encourage you to think about SciTech as a venue to do that. We had 6,100 folks there. So you imagine 6,000 of your closest friend engineers in one place. Super exciting. R&D focus. Is the largest aerospace R&D event in the world. It was packed house and super fun. We had 3,000 technical papers presented and over 2,000 students that attended. So a lot of energy in the house. You really get the feel of what AIAA is all about. And amazing keynote speeches on supercomputing, on AI and AI applications in aerospace. There was a lot of things on cyber, on additive manufacturing. Some of the things you saw today on that tour. You can see really the cutting edge stuff that's taking place, and a lot of companies are there. A lot of companies there to recruit and also to bring their young engineers to learn at those events. So really a fantastic opportunity to come and be with us. I'll just take a little bit of time to talk about why I came to AIAA and the growth that we're trying to achieve as an organization. So AIAA, as I said, it's about 30,000 engineers. Our goal over the next 5 years is going to try to grow it to 50,000 aerospace professionals. We want to grow the organization. We've got a lot of things going on at our technical committee level where we're going to be reorganizing. We've got a task force looking at that, trying to reorganize and find places for students and young professionals to get involved. We have a bit of a challenge with students and young professionals. You guys are getting all really involved in AIAA when you're students. And then when you go and you get your first job, we lose you somehow. We don't keep you in-house. We want to keep you guys in the AIAA family. We want to be important to you across the entire career arc. As Lindsay was saying, we've got a lot of things that we do at AIAA, which is not just the student branches and chapters, but our events, our forums, our publications, mentoring, and this is all relevancy across that whole career arc. We have a couple of folks here who are retired AIAA folks that want to get back. We have all kinds of opportunities from from the time you start in college to the time you're retired and done. You can still be involved in our events and what we do. And so there's lots of ways to get back, to learn over the course of your career. And we're thinking all about that in a digital world. So I grew up in an analog world. I'm that old. You guys are all digitally native. You started with digital. I mean, I can remember when I got my first computer and internet connection on my desktop when I was in the commerce department, and it was like a revelation, right? So I had a typewriter in college. That's how old I am. So what does that mean, though? I mean, so we have 200,000 technical papers and journal articles in our library. We have 500 textbooks. We have this huge catalog of material that we have to digitally transform that, make it AI searchable, make it relevant to you guys. We want to figure out how do we communicate better with students and young professionals. So I've told our IT guys, I want a Slack channel. I want Slack channels for all. You guys know how to use Slack, right? I had to learn Slack a couple of years ago. I was like, oh my God, this is overwhelming. And now I use it every day and I love it. But it takes a little bit, right? But we got to figure out better ways to communicate with you guys, better ways to keep you informed on what AIAA is doing and how to be relevant across that whole course. We want to grow internationally. I talked a little bit about the student branches that we're growing around the world. We have about 6,000 AIAA members, even though we're the American Institute of Aeronautics and Astronautics. We have 6,000 international members, and we want to grow that, at least double that. So we're thinking about different things we can do and hiring some people overseas that would help us grow with students, young professionals, and companies overseas so that they'll come to our events. I'll give you an example. SciTech, we had the German Aerospace Center, which is their version of NASA. They actually do aviation as well. They sent 50 engineers to Orlando. And so they're all presenting their papers there. They're excited to be there. They're excited to meet their American cohort and colleagues from NASA and other places around the industry. And so we want to figure out how do we grow the organization internationally. So we've got all these initiatives underway right now: digital transformation, student YP, international, all these things that we're trying to put together. I have a staff of about 72 folks in Northern Virginia where we sit, but we also have this amazing volunteer army of 1,000 aerospace professionals across the country and around the world that we can tap into and energize. So that's what I'm here to do. I'm excited to meet you guys today, talk to you a little bit more, and field your questions. So anything you got, and also help. I often get asked to provide advice and career advice, so I do a lot of mentoring in the industry, and I'm happy to help you there as well. So that's all I have for my talk. Thank you for inviting me. If you want to, do we want to do questions now or just go to lunch?
If you guys have any questions for Clay and those online that have questions, feel free to speak.
Don't be shy.
There's a question online.
Okay.
Mr. Rafi, go ahead. Mr. Rafi?
Mohammed, did you raise your hand?
Yeah, he raised his hand. But we gave the mic to him. I don't know why he's not.
If you're talking, you're muted.
Well, we're waiting. Any question? Yes.
Yes,
I
sir.
wanted to ask you, what do you know about computer science in the industry of aerospace?
Okay, I can tell you my experience on the computer science side. So we have a really hard time attracting talented computer science folks. And I will tell you, when I was at Blue Origin, our hardest thing to do was trying to find people that could help us do the software side of the rocket, right? So GNC, hardware in the loop, all the software oriented stuff. We were competing in Seattle, right, against Microsoft and you name it, Amazon, everybody that's trying to do everything. And so it was hard for us as an aerospace company to actually try to recruit in computer science, engineering, and people that could code and that wanted to do that. We had to really up our salaries to try to compete with the big companies that were offering a lot more stock and other cool, fun stuff. But we ended up figuring ways to do that, but it was tricky to recruit. I will tell you that as we talked about this digital transformation, but a lot of the stuff now, and if on the tour today, you probably saw they talk about trying to vertically integrate a lot of companies. So used to be they would outsource a lot of that stuff. Now they want it in-house, even in smaller companies. So I think there's a huge space for you to work in the industry. I can tell you there's a lot of talent acquisition folks that are going to want to meet you. And if you're passionate about space or aerospace in general, or aviation, there's a lot of stuff going on with automation now that needs computer science behind it, right? So the biggest trends, by the way, right now are AI, autonomy, autonomous flight, reusability and launch. You don't catch SpaceX doesn't catch a Starship booster with chopsticks without some serious computing power going on behind that, right? They figured that out and how to do that, and so anyhow, I think there's a lot of room for you there. Other questions? Yes, ma'am.
Would you prefer a computer science student who also understands and knows engineering and hardware?
Well, I worked for this guy named Jeff Bezos. You ever heard of him? Jeff Bezos graduated from Princeton University with 2 degrees, one in electrical engineering, another in computer science. He ended up working on Wall Street for a while, founded Amazon, but his real passion was space, and he wanted to go to space. And so Jeff is probably he's probably the smartest person I've ever met in my life and interacted with. And he quickly learned the all about rocket science, rocket engines, structures. He's an engineer's engineer at the end of the day, but I think his background in the computer and electrical engineering side affords him really an interesting perspective. I will tell you, at the Small Satellite Show that I've been to many years in a row that they do at Utah State, this year they're moving it from Logan to Salt Lake City. You'll meet a lot of aerospace engineers there, and they're like, gosh, I wish I had done more on the computer science side or the electrical engineering side, because I'm trying to build a spacecraft and I need to make it work. And so I need to figure out how to code, and I need to figure out how to do the electrical piece of this. So it's a little bit different, talent set. So I think there's a ton there that you can combine. I also think, look, in a lot of these areas, I'll give you an example of a young woman that worked for me at Blue Origin. Her name was Sophia Porter. Sophia went to Johns Hopkins University. She had studied applied mathematics, was her pursuit. She worked for me as a business development intern, but quickly she realized she wanted to get into the propulsion field. She didn't have any experience with it whatsoever. I had sent her down for a New Shepard launch in West Texas. She got to see New Shepard fly, and she said, I need to be here. I want to work at this facility. I want to work on an engine test stand and learn the propulsion side of the business. I couldn't get the team down there to even look at her for a while because she didn't have the background. She didn't have But when finally I said, look, she's one of the smartest people I've ever met. She's hardworking. She wants to work here. This is like her dream. They ended up interviewing her, and within 3 years, she was running the test stand. So it's absolutely possible to take, for her it was advanced mathematics, but like to take that, apply it, and then get into the more hardware and testing side of the field, which is a huge part of what we're doing. On the tour today, you heard about them testing out in Mojave. There's a lot of test stands like that around the country, around the world. So there's a lot to do there. But yeah, let me know as you go through your path too. It's also good, by the way, just from a mentoring standpoint, you can find somebody who will advocate for you inside the company. That can help a lot, right? And Sophia, just last week, I referred somebody to her. She's now working at an AI company. She left the propulsion side of the house, I think last year. She's also an artist and a singer. She's an incredible person. But I just got back in touch with her this past week and asked her if she would mind mentoring a couple of the students at Georgetown that I just met this week. And she was like, absolutely, I'll try to help them figure out how to. So that's something, by the way, look for mentors. And then once you get yourself established, get back a little bit, right? On the other end, once you get through the process, and you find that the first job, the second job, those are usually the toughest. But once you get the experience, you'll be on your way. You'll figure it out. Any other questions? All right.
Oh, wait a second. Oh, wait. Sarah, do you want to? Sarah want to say something. Sarah, do you want to say something?
Sarah, it looks like you're muted on screen.
Well, what happened was there are a couple of USC students. Suddenly they cannot show up today because they have a final project.
Well, can you look in the chat? Maybe in the chat. If you look in the chat, we can see the question.
Okay. Well, she's saying, fantastic presentation. It's truly appreciated.
Okay. Thank you, Sarah.
Yeah. She's the ADT team. Who are the ADT here? Yeah, with USC, they are going to compete in April in Arizona. They're doing fantastic project.
All right.
It's amazing design, so you will see they succeed there. But I do have a question because you just mentioned about the industry. So as Ian just mentioned, last year we did this event in spin launch. So as you can see, there are a lot of people show up with the facility. So the reality here in LA is that our students here, they are highly exposed to the industries. Mm-hmm. So they have very well connected to the industry. They can have tour, internship. So in LA, the student projects are very different from probably other places. So from our section point of view is that we don't get all the time, people like spin launch or impulse space, to support activity. And at the same time, the students are more attracted to if they can go inside the facility to see how people work. They are very excited to do that. But if we do it in a library, a lot of time they're just too busy. They cannot show up. So do you have any advice or suggestion how we can kind of build this relation with the industry? For example, honestly speaking, this event today, we have been planning last year. For 1 year, we try to do it in Jet Zero in Long Beach. There are a couple of exciting companies.
Yeah, I advise Bass Space, so I'd be happy to help you connect with Bass. If you want to see a space station getting built, it's pretty amazing.
Yes. Yeah, actually, the sections are limited in this aspect, and the students are ultra excited going to a facility doing events there. Mm-hmm. And of course, Ian said that UNLV, they got a flat tire. So that's another difficulty there. And we do have other colleges here. For example, Santa Monica College, we're from Santa Monica.
Right. Yeah, I forgot the Corsairs are here, right? Yeah. Yeah. I had to look it up. I'm sorry.
They want to establish a student branch there. So we need.
That's fantastic.
Yeah. And actually, we have been trying to get.
250. Make it 250.
Yes. So we have a lot of interest here. A lot of schools, El Camino College, Loyola Marymount University, Dominican Hills, Caltech, Dominican Hills. So we need help, to put interest, to attract them, to make them excited about AIAA. So we definitely need help. We actually also asked that space for help, but they are not very responding.
Well, you let me know. I'll help you. I would be happy to help you with that. I got the CEO on Slack, so
thank you.
I can tag him. Look, I mean, in some ways, you guys are great. The location here, because there are so many space startups in this area, it's really incredible opportunity for you guys. They view you guys as talent, right? Like they want to try to get you in the factory to meet you, They want their HR people to take a look at you because they're hiring engineers. They're trying to figure out. You heard the model that Impulse employs, very much a SpaceX model where they want to bring you in, put you with somebody who's experienced, work you pretty hard. You're going to get a lot of responsibility, and then you're going to go on to do great things. So if you're willing to do that and take on that responsibility, they're looking to find bright engineers, particularly ones that have, like I say, if you got team experience where you're doing things like design, build, fly, other things like that, where you've worked in teams. It doesn't have to be design, build, fly, by the way, but there's lots of things you can do in terms of competitions and teams where you can use that as a way to show your stuff on the front end of that. One of the things I talked to some of the other student branches about was, and you guys are doing it here, right, which is getting together with other student branch leaders. But we talked about, could we do some more things like that? And they all said, if you bring food, the students will come. So we got to figure out that. How do we figure out to do maybe some social events, some evening events, and how we put those things together where companies can come, support it, recruit, and we can have some food and socializing, and you can get to know and create basically a cohort, which is folks in your similar circumstance. Yeah.
Actually, that's another thing we need your help, headquarters help. Actually, Ian mentioned in the beginning, last year we did a spin launch.
Yeah.
So this event started back in Northrop Grumman as Cafe. So they were, at that time, before pandemic, they were very supportive. We have large facility. And exactly what we have, what you said, we're company going, lucky, all the company here, hiring managers. We even have high school coming here, educators. So we have exhibitors, hiring managers. So we intended to showcase our student branch and their project to high school, K-12 education. So our officer, all our officers from career, K-12, they all show up to support the event. But what happened, the situation in LA is that after pandemic, those companies no longer support this. So Northrop Grumman, right now they ask people inside to pay to sponsor. Otherwise, they don't allow outside people to pay or rent a room. We have Dr. Bushell, but even he has difficult to get the room secure. So and for other facility, is quite expensive. So we thank the library to support them with the.
Yeah, really, I appreciate the library support.
Yeah,
and a lot of times, universities will be able to host events. Sometimes companies can do it. I know at Blue Origin, we used to do a lot of hosting up at the Rocket Factory in Kent. But yeah, it's usually what you got to do is find a passionate AIAA person who works at the company that can, figure out how to crack the code for you, right?
Yeah,
to get in.
Yeah, this is what we need. Otherwise, we are limited by the space and also the participation from the company. But we love, that's our original goal. That's what you said.
Yes.
People come in and mixer, having fun. And actually, this evening we have a young professional mixer. And Luis, our section chair, will be here this afternoon. So we are kind of in a situation trying to go back to the pre-pandemic situation, but we are limited. So last year we were lucky to have Spin Launch supporting us. This year, Gary, they don't have a huge room, but they offer us a tour. So we hope to continue to work. For example, we just get connected with the company called Robinson Helicopter, thanks to Daniel. So we are going to have a tour over there as well. Yeah, Robinson responded. Thanks to
good stuff.
Thanks to Jim Sherman.
Yeah, Jim Sherman's our aviation lead at headquarters, so he's doing a great job.
Yeah, so we are planning to do exactly what your vision.
Fantastic.
Yeah, but we need some help after.
Well, we'll try to do whatever we can to support you.
Thank you.
Yeah. Okay.
Any more questions? Lindsay, any final words that you want to okay.
Thank you guys, really appreciate it. Thank you for your time.
We're here to give you plaques and certificates. Picture. Let's see.
Yeah, Luis is not here to sign it, but the tag is for you, and we'll mail the plaque after he signed it. We'll mail it to you. Okay. 1, 2, 3. Thank you so much.
Thank
Appreciate
you.
it. Thank you. Thank you. That's a good round of applause.
We're able to say
Say for what, one? One.
One?
One.
Okay, before one, we'll have to take a group photo before you leave.
Okay.
Right?
Good.
Thanks.
Yeah, sorry, the sandwich is a bit late, but they'll be here in any time. So, so please, network, talk to Clay and Lindsay, ask more questions, especially Santa Monica College, you want to accept the grant, this is a good time. Please ask them.
All right. So we're at the lunch break as of right now. The workshop will start at 12:20, but we can start early. I would like this to give you guys a chance just to network with anyone in the engineering industry, especially with Clay Mowry and Lindsay Mitchell, as they're here to answer all of your questions regarding about AIAA, especially for those who are starting an AIAA student branch like Santa Monica College. Feel free to ask them any questions about anything that you have in your mind. Okay. All right. So if there are no other further questions, we'll be in for a break. And then for other student branches who are here, if you have any exhibits that you want to showcase to everyone, especially with Lindsay and Clay, feel free to do so. Thank you.
Well, actually later, we ordered the sandwich delivery, but it's not here.
I don't think that's why I'm making it 3 out of 6 or something. I can't do them all.
He is traveling.
I have not all of those, but some of them are pretty confirmed, so there's no way I can make all 6.
Yeah, there's one that has like 3. So Bob and I.
Oh, yeah.
Yeah. No, we're on the low side. We're at 60. No, they have
This lobby, because they get the guys down with Dallas.
We're like
I
at
know,
60.
I'm really hard to get
Pretty good.
the thing.
Oh my God.
You have to.
Some of the cool staff stuff. We're at 60.
Yeah, we're gonna get, staff.
Oh my God.
And then Meredith just coming over, right?
Hello, everyone. We'll continue on with the event. So next up will be the AIAA student branch presentations. We'll first bring in Cal State Long Beach AIAA, then UCLA, then we have the air design team that will present their presentation. And unfortunately for UNLV, as what Ken said, they had a flat tire on their way here, so they won't be able to join us. But hopefully, they'll be able to join online. I'll have to keep in check if there are going to be. But if not, then after the air design team presentation, we'll skip through the UNLV and then we'll head over to David's presentation. Okay. First up, we'll have the Cal State Long Beach student branch ready. So everyone from Cal State Long Beach, you want to present?
Is this one? Wait, do we use a microphone or we don't need it?
Use the microphone in case there's any online audience.
This one?
And
It's
then
online.
Oh, it was off.
Yeah, you can use either one or both.
all yours. Good afternoon, everybody.
I'm Matthew Alcazar. I am the president at the Long Beach State AIAA student branch. And from, I guess we'll start from left to right, or my left, no, too late.
Sure.
Yeah.
My name is Pedro. I'm the CubeSat development project leader at SharkSat.
Hi everyone, I'm Aryan. I am an officer for the AIAA branch and the treasurer of SharkSat.
Hi, I'm Aaron. I'm the chief engineer of SharkSat.
I'm Julian. I'm our student branch's treasurer and one of the project managers for our DBF team.
Hi everyone, I'm Cassandra. I am the project manager for our rocket team, Ezra.
Hi, I'm Pedro, vice president of AIAA.
Great, and we're just gonna start now, yeah. Just did our introduction of what our org is on campus. And so I'm gonna start with what our chapter is and what we do. Top to bottom, you see we start with our GBMs. We try to have guest speakers come speak to our members so we can learn about different kinds of skills in industry and then technical experience that they can teach us. We also try to get tours, and we have, like, I guess I could say, an advantage considering the area we're in. We're in Long Beach. There's a lot of startup companies in the area, so it's easier for us to get a tour. And like, I guess we have some examples. We recently had one at Astro Forge. We're setting one up at K2 Space. We have Varda also being set up, SpaceX, which was last year, but and then also we have VAST, which last semester, no, just earlier this semester, and Relativity, which is another one we're trying to set up. And again, this is all thanks to our actually a group of people that aren't here, industry representatives that couldn't make it, unfortunately. But yeah, we have a whole team setting these things up for us, and they've been a big help. And another thing we try to do is off-campus events. We try to go out and speak to K through 12 students to kind of inspire the next generation of engineers, especially because, like, some of us, especially myself, I'll be honest, I didn't know about aerospace before I got to school. So it's nice to go talk to younger students, younger kids who don't know anything sometimes. And you can talk to them and teach them about what they can do in the future as an engineer, especially an aerospace engineer like us. And then, of course, the most important thing that I'm pretty sure a lot of people are interested in are project clubs. So we'll start with those, actually. Yeah, and then, yeah, again, how we mentioned earlier, we have one representative, namely leads for each club. So we have Ezra, which is our rocketry club. We have Long Beach Aviation, which is our aeronautic club, and SharkSat, which is the course set up there, CubeSat Project Club. They're brand new on campus, and they're kind of our crowning jewel at the moment. Yeah, first, Ezra.
Hello, as mentioned before, my name is Cassandra, and I am the project manager for Ezra, or Ezra standing for the Experimental Sounding Rocketry Association. So we are a competitive rocketry team at Cal State Long Beach, and we're currently looking to participate in the 4-hour competition later in May. Our focus is to design and construct experimental rockets, but we also allow our members to kind of delve into different rocketry adjacent projects, like a scientific payload that they can fly in the rocket that's already built. Our goal is to provide students undergraduate research opportunities, a chance to get hands-on projects and work on novel rocketry projects and advanced rocketry projects. And through these endeavors, some of our alumni have gone to work at ABL, Rocket Lab, and even Blue Origin. So in the past, Ezra has developed a modular rocket body that has the capabilities of housing both a solid propellant system or a liquid bipropellant fluid system. And that's done by having an internal sled that's able to slide in and out of a basically hollow rocket body. And back in February of 2023, we launched our first rocket Persephone to an altitude of about 10,000 feet. I have a video of that launch. I don't know though. No?
Next slide.
Oh, that's fine. We can go to the next slide. I think it's just the sound. That's fine. Well, but we're currently working on developing a liquid bipropellant fluid system to be housed in that same rocket body Persephone. That again will be held on that internal sled. So through methods of multidisciplinary optimization, we've created an engine sizing code that outputs various engine designs based on their flight parameters, so altitude goals, propellant combinations, O-F ratios, and things like that. And then we go in and determine which design best fits our needs and our manufacturing capabilities, since we do make all of our components in-house. So on the right over there is actually a CAD of our engine Hades that will fly on our rocket Persephone. So we do have it actually manufactured, but pictures don't do it justice because it kind of just looks like a cylinder because it is a heatsink. But again, you can see internally we do have the basic structure of what a rocket engine looks like. And then once it's developed and tested, again, we're looking to fly the system at the bar competition. And then on the bottom, that's just what the internal structure would look like as the sled goes inside of that rocket body Persephone. And I think that's it for me.
Hi, I'm one of the PMs for our only aeronautical engineering project club on our campus. Long Beach Aviation is what we call it. We primarily participate in the AIAA Design Build Flight competition. Some things to highlight is that we are open to everyone, regardless of experience or major. DBF is awesome because it's something that you can come in with absolutely zero experience. You can be a freshman in the MAE 101 class, and we'll teach you everything you need to know besides building control, because that stuff is really hard. So some of our primary goals is to develop the membership's technical skills, knowledge, and intuition in aircraft design. The other really important thing is representing the school in intercollegiate academic competitions. We find that there's value in taking pride of our school and being one of the top California state schools, and most importantly, just to learn and have fun. There you go. And then what we do. So just to recap, LBA was actually restarted, fresh new leadership for the first time since COVID, literally just last academic year. And thankfully for submitting a proposal for a fresh new team restarting the project, got into the competition by the skin of the teeth. I think it was like 107 something, barely got in. So that was awesome last year. We placed 59th out of 107 universities that attended the fly-off in person. We saw this as a huge success considering it was the first time participating in this competition since restarting it since COVID. And then additionally, considering the fact that we entered the competition with a flight line number, like a Q number of 90 out of 110. So dropping effectively 30 places was a huge win for us. And then just some of the highlights I'm sure every single person here is aware of, we write a 6-page proposal to get in, 50 to 60-page max, fully detailed design report, and then obviously fly off in person. Yeah, that's what we do at LBA.
Hello. So where are sharks at? I would like to say, does anyone know what a CubeSat is? Raise up hands. I think most of you know. For those who don't know, this is what a satellite or a CubeSat looks like. It's a very small version of a satellite. So we're the first cube satellite or development satellite team at Castle Long Beach. We are mapping out blue light pollution I'll get into the next slide. But the cool thing about our team is that we entered a NASA competition last year, NASA CSLI or CubeSat Launch Initiative. And we've been fortunate enough to have many advisors, along with NASA, support us on this journey to sending our first satellite to space. Next slide, please. So what is our goal? Our goal, once again, is to design, manufacture, test, launch, and operate a satellite in space. We're going to be monitoring blue light pollution, essentially a Earth observation mission. Why are we doing that? Because the current state-of-the-art technology is kind of missing that gap. And so we're going to be covering that. Additionally, as long as with my other peers, our main goal is to educate our community, not only about the mission, but just in terms of engineering. Many of us came from underrepresented communities, and so inspiring the next generation is really important to us. But yeah, we're starting to get into the fun stuff in which we'll have high schoolers and middle schoolers help us manufacture these mock sats or CubeSats, and then eventually have our name in space. Next slide, please.
That's all for Long Beach today, and any questions? Thank you for listening.
A quick question, I missed what you may have said about flat stuff. Can you just say a couple of words about flat stuff?
So SharkSat is currently finishing up our preliminary design phase. And so over the next couple of weeks, even months, we'll be moving into FlatSat stage, where we're essentially procuring our initial components, getting into our lab space, and building our FlatSat. A FlatSat is, for those who don't know, where you gather your components, put them on a flat table, and test out how they work, essentially.
So basically like a test bed.
Exactly, a test bed, yep. Any other questions?
I was curious what the far out competition is. I haven't heard of that.
Yes, the FARO competition, I think it's a fairly new one, similar to the IREC competition that's held by the actual, I think, national branch of like ESRA. But we opted out of that one just because logistically, it was a little bit out of our reach in terms of funding and travel. But the FARO competition is essentially the same thing. It's just held out at the FAR Mojave test site, which we were out there all the time to test our engines anyway. So we thought that was better. And as for our first time competing, that it would be an easier competition to participate in. And then maybe later on, we can look to participate in the actual national branch competition.
Oh, wait 1 second. Somebody want to ask a question?
Yeah, I think that's, we got it.
No, I'll make that person speak out 1 second. Especially he says something himself. Okay, go ahead, Mr. Kirk.
Yes, hello. It's great to hear from you. And my question is, this is Guanghan from Grand Systems, and we have some email exchanges. My question is, what are the most challenging part of owning a space mission for the SharkSat?
Yeah, that's a great question.
I do have different answers.
As a technical lead, for me, the most daunting part of it is just the sheer amount of technical responsibilities and different components and things of that nature that go into making a CubeSat. Off the top of my head, I could name 6 or 7 subsystems that we're working on right now. And each of those teams is individual. Each of those teams has its own leadership, its own subcomponents. And it's a very complicated process. And Pedro, I'm sure, can speak better on this than I can. But on top of the technical side, there's a lot of management. There's a lot of bonds that we need to have forged. So we need to make relationships with a lot of industry professionals, a lot of companies. And because we're a student group, we obviously don't have a lot of money. And so those relationships are really important for us, hopefully to get discounts and other items of that nature. But also filling out paperwork, getting licenses for the FCC because we're an Earth observation mission. It's just it's a very, very large puzzle, and each piece is very small.
Yeah, Aaron mostly covered that, but yeah, just a lot of project management. Yeah, you kind of covered it all, but yeah, just the project management aspect. There's a lot of moving parts, and sometimes it feels like not enough time, but we try our best for sure. Next question.
Can you elaborate on the fundraising portion?
Yeah, so fundraising, I will say, has been, even though it's very difficult, we've been very successful at it. Over the past year, I would say we raised like $60,000. That being through crowdfunding or donations or sponsorship packages. But yeah, it takes a lot of work just getting the right publicity out there, making those connections, and just trying your best to stay true to your word. Yeah. Any other questions?
One last question. Can I just ask, what was the mission for your DBF team?
Yeah. So, are you talking about last year or this upcoming year? Last year. Last year. Yeah. So our plane is actually back there. I should have mentioned it. That's its name is the Mosquito. Um, Prototype, first iteration, final design, and the competition aircraft that was flown 4 days for first time 4 days before the competition. So we're super proud that it generated lift and didn't crash on the first maiden flight. Like it's actually very normal for a lot of teams. So we're very fortunate that our analysis and the hard work that went in beforehand was right. But essentially, last year's missions were the two main ones, or the general theme was urban air mobility. So as you see, there's a folding wing mechanism. One of the the rules requirements was that it had to fit within a certain small space, as if it was like a real, helicopter that had to be deployed into the city or something. And then also that it could take off in a short distance. That's essentially the gist of the theme of the competition last year and some of the requirements that we had to meet. Is there any follow up on that or answer that? Any other questions? All right, thank you. You said last one. Oh.
Yeah, we're gonna move on. So
Okay.
LB,
Sorry.
One round of applause for Council Lobby. And then we're done.
Okay. Great, thank you. Yeah, that way, yeah. One. Great, yes.
It's a bit far from me, it's fine.
Another one, thank you. Excellent, thank you.
All right, thank you. Thank you. All right. All right. The next presentation we'll have UCLA.
As you can tell, there's only one of me. That's okay.
You got the clicker?
What?
iClicker? The clicker where you just change slides? All right, cool.
Yeah. Okay, hi guys. It's clearly just me, but that's fine. It was a very busy time at UCLA between the design report being due and various launches for our teams. So I'm going to do my best to represent all our project teams, but alas, I do not lead them all, so I'm going to be doing my best. So this is me. I'm an aerospace engineering senior at UCLA. I'm the president of our AIAA chapter, as well as last year I was the project manager for our DBF team. So our AIAA branch at UCLA focuses on three main things: professional development, academic support. Okay, is this better? Okay, you can all hear me. It was off. So we focus on professional development, academic support, and our 4 technical projects. The events that we've had this year include our AIAA kickoff meeting, an MAE MSE career fair where all of the MAE orgs at UCLA combined to invite companies around 20 to 30 to come and speak at UCLA and meet the students. An L3 Harris info session and various social events. Some upcoming events we have are a departmental town hall, an industry advisory board meeting, some technical workshops, and hopefully an info session with Air Lease Corporation and maybe a launch viewing at the Aerospace Corporation. We have 3 committees that make up our AIAA branch at UCLA: external, financial, and internal. External handles a lot of the technical or the professional development amongst our members, so a lot of outreach with different companies, resume workshops, things like that. Financial committee handles a lot of the finances and industry donations for our 4 technical projects, and internal handles a lot of the logistics within UCLA.
Oh, it's the Wi-Fi, sorry. We share the screen for Books online. That should be okay.
This clicker does not like me.
Oh, I see. Try again.
Okay, thank you. Okay, so these are our 4 technical projects that I've been referring to. We have Design, Build, Fly, Rocket Project, UAS, and Bruin Space. So planes, rockets, drones, and CubeSats. So I personally was the project manager for DBF, so I can answer best to any questions about this project team. Our missions are generally to help students learn how to apply the theory that they learn in their classes, because UCLA is very theory heavy and our classes don't get too hands-on until you're about to graduate. So the projects are really good for that. And just developing general team and leadership skills. So these are our last 2 aircraft, Corn Dog and Bear Bus. For the last 3 years, we placed 16th, 15th, and then 14th in a row, which we are very proud of because we are aiming for 10. So hopefully we'll jump straight to 10. But yeah, so that's Corn Dog on the top because it looks like a corn dog, and that's Bear Bus. So the theme this year, as I'm sure all of you DBF people have seen many, many times already, it's an X-1 supersonic flight program. So it involves an autonomous glider deployed from the aircraft to land on the runway. And our goal, as many years, all years, is to place top 10 internationally. So the way that we train our students in this project team is through a class called E96 Planes. We are very fortunate to have these types of classes at UCLA. We essentially have undergraduate students come in, and we have undergraduate students teach the class who are in DBF at UCLA. So they get taught everything about aircraft design, SolidWorks, MATLAB, everything that would go into it. And then we also have a 10-week new member training program that is directly taught by our club. So the next one is Rocket Project at UCLA. Their mission is to design, build, and launch 1 rocket per team that they have. And they have grown 5 times in the last decade, so they're a very large club and the only rocket club at UCLA. The way that it works is they also have an E96 rockets class. They have students launch small solid rockets, and that teaches them the general basics of rocket design. Then they move on to Prometheus, which is hybrid rockets. And finally, they move on to Ares, which is a liquid bipropellant system. So Prometheus competes in the Spaceport America Cup. And from what I hear, they're doing very well. Again, I can't directly vouch because I'm not on this team. But yes, they are hybrid rockets. And then the more advanced members who are 3rd and 4th years, they compete in the dollar per foot competition and liquid bipropellant rockets. I hope you enjoyed this slide because we can't leave it.
And I think the Wi-Fi is not very stable.
Okay, that's what I thought too. It was lagging when I joined online.
Okay. Try again. Sorry for this. So basically, just have to reshape it. Just lower it.
Cool. So yeah, this is the last thing that they have their RISE program, E96R, which is how they onboard their students. They actually make this mandatory before you're allowed to join the club, whereas DBF makes it optional, I believe, because there's more safety at stake here. They also do a lot of outreach to local schools, so elementary schools, middle and high schools around LA. They do
virtual and in-person visits to just teach them about rocketry. Some photos. Next is our drone club at UCLA, UAS. So they develop one drone per year, competing in the SUAS competition. So they are supposed to autonomously navigate more than 12 miles with obstacle detection and also airdropping cargo. So they have a fixed wing drone. It's the one on the bottom right over there. Yeah. They have three different sub-teams: computer vision, flight software, and airframe. And they also have an E96 drones class where people get to learn all of the basics on how to build and code drones. And the last one is the CubeSat project team, which is Bruin Space. So they're trying to make space accessible to students. They have 3 different sub-teams to their team, I guess. So Rapid and Overseer are both technical, and then Forge is their professional development one. So this is Rapid. It's more of their, I guess, technically proficient one. They do fully built CubeSats. And Overseer is more to get students an introduction to space and CubeSats. They do a high altitude air balloon, and they let them release them, I suppose. So that's what they're doing right now, actually. It's the reason they could not be here. And the last one is Forge. So this team has a huge emphasis on trying to get into industry. And in addition to AIAA having info sessions from companies, Bruin Space also has a lot of info sessions from companies. So those are our 4 project teams. Thank you.
Thank you for the presentation, and here's a certificate for your presentation.
Okay, smile. 1, 2, 3. 1, 2, 3. Thank you.
Thank you.
All right, the next presentation up will be from the USC ADD team.
All right.
Turn on the mic.
Thank you. Okay. Hello, everyone. We are the USC Air Design Team, or ADT for short, and we're going to go over what our team is about. So is this the most one? There we go. So about us, we are USC's entrant into the into the AIAA DBF competition. We've been around since 1998, and we fly electric remote controlled aircraft. There we go. Okay, so we've been in these competitions for a long time. As you can see, these are only a few of our most recent aircraft. We've had a lot of wins from many years before this, but just to go over a few. And also you can see the variety of our aircraft right here. I'm guessing that the DBF teams would know all about this, but just to show that, you can see that we have one aircraft over there. I believe one of these might be 2017's plane is even smaller when it's folded up. One of the requirements was that it could fold up, and it won that competition. Meanwhile, 2022's airplane was, I believe, an 8-foot wingspan. Could also pull 10 Gs. I think I'm getting at somebody else's slide there. Also, reports are a critical part of our score in the competition. So you can see that one, for example, right there, 2020 had the best report, and our last year's aircraft also had the best report. All right, I'll pass it over to you.
Yeah, so this is one of our fun facts. We had like 13 top 5 finishes, tied first place on the list of top 5 finishes in a DBF competition. As Matthew explained, Vaccinator, which was 2022 DBF plane that can withstand a 10G turn, which which was also at the maximum RC level weight as well, which is 55 pounds. And then the Transformer, which was the 2023 DBF plane, wing can hold 1,600 pounds as well. So yeah, this is our team schedule. So we starting from around June when we have our lead selections starting from on May. We start our summer plane starting from June, July. That's when leads get to know their position, learn about their position, and gets practice before building the actual plane. After like August, September, the DBF rules comes out in late August and early September. So that's when we start the preliminary design and the constraint analysis. And then we have our preliminary design review around late September and early October as well. And then after that, we have a critical design review around January to February. That's right after winter break when we work on our to refine our analysis and hardware design processes. And then we have our manufacturing and competition prep for February and March, and we participate in DBF, which is held in April.
It's not working again?
Yeah, it's not.
Let me see. You can see the mouse. So if you see the mouse, that should work.
Get live, so we got Okay, so a little bit about our team. We separate our team into 14 leads, and in total we have about 25 active journal members. We actually have gender parity on our e-board for the second consecutive year, which is something we're proud about. We have 3 sub-teams. One is the analysis, and then we have hardware, and then we have our logistics team. These are just some of our team leads. I guess we can introduce ourselves. My name is Jenna. I'm the build lead for the team.
I'm Matthew. I'm the landing gear lead.
And I'm James. I'm the flight test lead.
I'm Natalia, and I am not a lead.
So a few new things that we've been working on. One thing we have is a CNC hot wire machine that we kind of learned how to build in-house with some support from the makerspace on campus. We also want to train new student pilots in RC flying. And we also do a lot of social and industry and community service events. So this is an example of a project we've been working on. One of our members kind of piloted this, but it's an in-house built CNC hot wire machine with funding by our makerspace. We use a lot of foam-based structures on our aircraft, so this is something that helps us get really high precision. So it's something we're excited about, and it really expands kind of our manufacturing capabilities.
Hi, I'm Natalia. As mentioned, I'm not a lead. I'm a first year at USD, so I can give the perspective on the new things and the experience as a first year. So as Jenna mentioned, there's the student pilot initiative. And so a lot of people on the team were like making our little foam, well, not really little, but they're kind of little foam planes and flying them around at test flights, which is a bunch of fun and a new experience. And we also have a lot of events, which is super exciting as a first year to be able to go to. At the beginning of the year, we had our desert trip, which is really great for community building and getting introduced to the team, which is also where we fly the summer plane. And we have the preliminary and critical design reviews, as well as some volunteering, which is super fun because we were making these little gliders with elementary and some high school students. And some of them honestly had better ideas than us, which is super exciting and super fun to see. And then we also have all of our flight tests, which are fun, early mornings, but really fun and exciting to go to as well. And then these are ways that you can connect with us on Instagram. And I can't see the label for the bottom one, but it goes somewhere as well. Oh, it's our website. Yeah.
All right, thank you, USC AUT. Here's your certificate of participation. Thank you.
Great job. Thank you. Yeah, hold it, hold it. Yeah, 1, 2, 3. 1, 2, 3. Another one. One second. Thank you.
Thank you.
Wonderful.
Thank you. All right, so the next presentation was supposed to be from UNLV, but unfortunately, like I said, they won't be able to join. They had a flat tire on their way here. But I will say this, that for UNLV, they've been active when they're on their airplane projects, especially for 3D printing, and they always find ways to have interactive workshops to participate and give with their students. So that's pretty much what they've done the most part, and then they'll be here and then finding ways to encourage more students to join AIAA. So that's all I can say for UNLV at the moment, from what I remember from the top of my head. But we'll then move on to the next presentation, will be from David from USC.
Now I think it had a back, please. So it doesn't go away.
I try using the arrow keys.
Yeah. Did you see the clicker over there?
The clickers in this computer. That's what's controlling.
Oh, I know what it went. The mouse.
PowerPoint's not there.
Okay, Dave.
Oh, yeah. Oh, there we go.
You have to put the mouse here.
Yeah, perfect. All right, I'll just go ahead and get started. Hello, everyone. My name is David. An acknowledgement section at the end, but before I even begin, I just want to extend two special thank yous. One to the advisor for this project, Dr. Spedding, always accepted very promptly to guide me through these projects, and thank you so much for doing that and for being very patient with me while doing so. And another very special thanks to Ken. This is the third time that I give the presentation on this project. The first was at a lecture at USC, and we had another session like this a couple of months back. This is a condensed version of that, so I'll try to chug through it very quick. But I have a lot of fun with these, so thank you so much for the invitations. Again, I'm very happy to be here again. A little bit briefly about myself. My name is David. I am a junior at USC. I was with the wonderful aero design team for my first 2 years. I'm a junior now, and just this year with a couple of other colleagues, I'm starting a human-powered flight research team. So we're trying to get a human-powered airplane in the air by the end of next year. I've also participated in AIAA conceptual aircraft design competitions in my freshman and sophomore years. These are some of the projects that I've worked on. This is basically every airplane that I worked on in college, one for my internship last summer. And this is what the human-powered team has been up to. Notice the lack of a human-powered airplane. We're working on that, but we had a fun opportunity to go out to Red Bull Flugtag, if anyone is familiar with that competition. Somebody reached out to us and asked us to design an airplane for them, so we went ahead and did that. So now we're actually working on a human-powered airplane, see how long it takes for us to get this cracked again. So I'm here to talk to you today about my design for last year's conceptual design competition. It is about geoengineering. So the idea for this talk is that I'll give a little bit of the motivation behind the competition. I'll fly through my design very, very quickly, try to keep this under 20 minutes, and then I'll talk about some work that I've done after the competition, developing some tools for performance sizing. So cool, some of the motivation behind this competition. In 1997, two scientists
wrote what was essentially a compilation of quantitative data into the radiative forcing from different processes within the Earth's atmosphere, and compiled this into what is now known as the trend birth diagram. And in the context of global warming, it's a good question to ask, how can we address the problem of rising surface temperatures? Looking at this diagram, there's basically two options. One of them is the one that people are most familiar with, sequestration techniques, which is essentially decreasing the amount of radiative forcing that is kept in the Earth's atmosphere by outgoing rays. But another thing that you can do, and it's what this competition was all about, is to address the left side of this diagram, which is to decrease the amount or increase the amount of light that the Earth reflects in an artificial way. The motivation behind this is following volcanic eruptions. There's a trace under the plume that sees almost 2 degrees Celsius decrease in the surface temperature. And so the idea of doing this artificially comes from analogous studies to natural situations like that. Some of the pros are surface cooling. That is the main goal, but there's a lot of still being studied negatives. This is a very, very new topic, including most predominantly ozone damage. A lot of these aerosols are sulfur-based. There's a huge campaign against CFCs a while back, and all other sorts of uneven pattern-changing things. So this is a very, very hot research topic. But it is so early in this that some people are already doing it. So there's a company that's been launching sulfur dioxide balloons. Some people call them, trailblazers. A lot of people call them, uninformed. And so this is a very hot topic in this geoengineering field. But this brings me into the topic of competition, which is doing so artificially injecting aerosol into the atmosphere. The idea is that there was a paper by some very smart people. It was a joint study by Aurora and some universities, where they looked into the opportunity of aerospace jumping into this and whether this makes sense for aerospace to design aircraft that loft a bunch of aerosol into the stratosphere. Interestingly, they concluded that not only does it make sense for aerospace to jump on this, it might be the most economically viable option to have a new aircraft design to do so, which is a very interesting conclusion. A lot of uncertainty surrounding new technology and availability, but that's addressed in the paper, and I'll address it in a little bit. How much aerosol is a good question to be asked. For the competition, it was assumed from the results from this paper that estimated that a very, very large fleet size, around 200 airplanes flying 3 sorties per day, you would have an aircraft fly 30,000 pounds of payload to 65,000 feet. This is a very novel design point. Aircraft design, there's no such airplane that's capable of carrying this much amount of payload into such high altitudes. And there's also some unique performance requirements. These airplanes for dispersion need to fly within 15 degrees of the equator, so there's some ferry range requirements that are part of the competition as well. So these were the rules for the 2024 competition. You are to design an airplane that will fly at 65,000 feet and carry 30,000 pounds with a range of 400 nautical miles, so 400 nautical mile range out and back. Also important to note that the context of this is that if these very smart people decide that this is indeed safe for the environment to do, then what would an airplane that does this mission look like? So yeah, a little bit about my design. I'm gonna fly through this because I have a lot of cool plots from code to show. But this is just basically the process of designing, and these are student design competitions. So this is generally what somebody would do, sort of an aircraft design. I guess you could call it a crash course. The big performance problem here is the atmosphere. The density ratio at 65,000 feet is around 7%. So that is a direct, proportional hit in lift. But perhaps the even bigger problem is the thrust loss. So even the lowest fidelity models assume that the thrust goes with roughly the square root of the density ratio. So that's already a big hit in propulsion. But some more detailed models, so a lot of the analysis I did used Mattingly models. That's a 5% hit in propulsion from the atmospheric loss of flying at 65,000 feet. So that is a big ouch in propulsion. These are some similar designs that would do a mission at similar flight conditions. You can see very, very interestingly, if I'm accurate with the laser pointer, if I use the right side of the laser pointer, that's more important, that the U2 has a thrust rate ratio of around 0.6. So has anyone seen a U2 takeoff? It is a phenomenal thing. It takes off and climbs like a rocket because it has a big thrust mismatch. It needs to carry so much extra thrust rate ratio at sea level just to be able to sustain flight at 65,000 feet, which is interesting. It's a problem that's shared that's shared by seaplanes as well. I worked on a seaplane last summer, but then it's the opposite. You have so much hydrodynamic drag during takeoff and very little drag once you get off the water. The idea for a blended wing body here came from some configuration opportunities. So it turns out that the payload density is not that bad compared to the internal volume that you would already have, just you have the wing area that you need to fly at 65,000 feet. So this was a study by some Yale researchers. They did a configuration that had a very small payload volume fraction compared to the tube and wing design. So there's some opportunities there, as well as just generally the ConOps work out favorably. You need generally a pretty low height for loading and unloading payload if you're flying 3 sorties per day. And many of the problems of wing bodies are diminished here. There's not an issue for takeoff rotation. You have so much extra thrust when you're taking off. And this thing doesn't have to be very, very pressurized. This assumes a crew of 4. So yeah, okay, so I'm going to fly through this very, very quickly. But here's the process generally of designing airplanes for these competitions. If anybody has read books like Raymer's Aircraft Design, this is kind of like the process that's outlined there. But you start with a constraint analysis. This is looking into a first design point, usually a thrust rate ratio, and a wing loading. So you would plot different performance constraints and select a starting design point there. You can also do sort of the inverse of that, which is a it's called parametric baseline trace, but really is a sensitivity study. So the opposite of picking a design point is you pick a design point and then you vary it by a little bit and see how the performance parameters change. So I did a little bit of that. Weight estimation in conceptual design is generally done with historical weight fractions. And if if you're working at a novel configuration that might not have very accurate weight fractions, and you are conveniently an undergraduate student, you can add fudge factors that land you pretty close. You can't do that in industry, but for a first shot and before using more accurate weight models, this generally works. In this sort of problem, the configuration is very, very tied to the aerodynamics. These airplanes fly at close to transonic speeds, which has its own problems being closer to the coffin corner. But there's a pretty close tie to selecting an airfoil that gives you enough internal wing fuel volume and other configuration challenges that backs out into changes in the aerodynamics. So there's some back and forth with that as well. Did some weight and balance analysis, excursion diagrams, all those sorts of things. Generally for these compositions, that's they lay out the requirements and what sort of diagrams they want to see. And last but not least, a bunch of analysis, aerodynamics, propulsion, a bunch of different propulsion models. Try to always try to use some scaled engine data, kind of like an engine deck, and also some analytical models, and a little bit of performance analysis. So just after going through design iterations, you verify that this thing can indeed fly at 65,000 feet. Okay, cool. The fun part now, or at least fun for me, hopefully it gets entertaining. But this is a highly interdisciplinary problem, and right after I finished this competition, I started working on some codes. I actually started working with a colleague for a class at USC, so shout out Nicholas. We developed some time-based, basically integrates the ODE of an airplane over a fixed mission profile. I took those codes, put some shared geometry and weight parametrization things, and added some other little things, and became kind of a pretty robust early conceptual design trade study tool, and figured what would be the kind of results that you would get if you run this sort of problem with a tool like that. And I learned some lessons. But before, a little bit about this tool, which I call DS Aero Tools. It's essentially a compilation of every piece of code that I've written in my undergrad. But it can do something like this. So these plots are probably for the DBF and other project teams are familiar with this, but this is a typical trade study. So each point there is a single geometry that can be simulated over a mission. And then you can back out and plot and compare different performance constraints. So the idea is that the output of a single mission, a single geometry that converges a single mission is something like that. You have a bunch of time states of all sorts of states, altitude, range, forces, so lift, drag, coefficients. And then you can use those in post-processing to compare and pick a somewhat optimized design point. So this is how the code is sort of structured. A vehicle model is the high-level main class. A bunch of different things feed into it. So you have a geometry and a weight model. a bunch of aeroforce related models, and finally a propulsion model. And the modularity in this comes from being able to switch out these models to solve different problems. This is how a mission is converged. So it gets a set of inputs. You define a mission profile. So this might be a simple takeoff, climb, cruise, descend, or it might be a more complex takeoff, climb, cruise, in this case, while dispensing payload, descend, and you can add loiters and a bunch of things. And you converge on a mission. I'll elaborate on this, but essentially you're just checking that some state at the end matches a convergence criteria. And at the end of it, you can get a vehicle JSON, which will have all of those time series, and you can use those to compare the performance of different planes. And this is the useful thing for this competition that had some, some ferry range requirements. I've set it up so that you can run this in two different ways. You can run it in a mission fixed or an energy fixed. So the idea is that a mission fixed will converge by varying not the mission, but the amount of fuel at the beginning. And the convergence criteria is to just check the final amount of fuel should be equal to 0. Whereas energy fixed is useful if you want to find out with a fixed amount of fuel on board, how far can I fly? So what it will do to converge is it will vary maybe the range, the cruise range, until all of the initial fuel is burned. And this is, not as trivial of a problem because there's this is an implicit problem, right? Because when you finish the range that you're trying to solve for how far you can fly, you still need to fly a little bit more, and maybe the end, so maybe the descent has another varying segment that you can also try to iterate until you can use up all your fuel. So I did some validation studies. Maybe some of you are familiar with SWAVE. This is Stanford, a pretty popular Stanford conceptual design tools. I validated this with a 737 case, and results matched up pretty well. So here are some numbers. 5 or 3%. If it's within 10%, it's probably good enough for conceptual design. But this was encouraging. And yeah, so some lessons learned from this, and this is a work in progress. So this is just adventures into these weird numerics. So first of all, there's a lot more work to do. A lot of these numerical models that we learn are not very fit for very computationally iterative sort of work. So this is an example of a compressible drag model that we learned in our flight mechanics class, which works pretty good for most flight envelopes. But when you try to run an airplane flying at 65,000 feet, it starts giving you trouble. So this is an example of a run from an incompressible case and a compressible case flying the design mission for this competition. So this is a climb to 65,000 feet, cruise for 400 nautical miles while dispensing payload, descend a little bit of a loiter for reserves, and then land. And you can see that if you turn on the compressible model, you start getting trouble. And if you conveniently, you get those vehicle JSONs and you go look at the drag versus time. Oh boy, a drag coefficient of 50 is a very, very poor, designed airplane. I'm a performance person, so when I try to, get my hand on, and try to build foam planes, I probably get a CD of around 50. So yeah, no good. So there's some work to do there. One solution for this would be to incorporate something like a surrogate model for compressible drag or something like that. But despite these challenges, I decided, let's try to run this in a sort of in a what you would do for a trait study and see what kind of results you get. So conclusion number one, and this is kind of expected, but ferry range is not really a problem. Even burning quite a bit of fuel, of extra fuel from all that extra drag, all these airplanes satisfy the 3,000 nautical miles, no problem. The problem is thrust. And so again, this is with the kind of wonky compressible drag model, but you get an interesting area where the code predicts that you can fly at 65,000 feet without the throttle required being greater than 100%. By the way, the being greater than 100% just means I'm just dividing the throttle required in cruise by the throttle available. So this is a way to check in post-processing if this airplane is capable of outputting the thrust. If the value is greater than 100, it means your engine is undersized. And if you were varying the thrust available in a more detailed trait study, you could repeat these studies for a bunch of different thrust availables at sea level or some fancier rubber engine models. But the interesting thing is that it points to this region of finally being able to cruise with the thrust available, sufficient thrust available to overcome the wave drag. So an interesting study would be to see if this is physical with more accurate compressible drag models. And yeah, there's a lot more work to do. I included in the next steps for this, what I'm actually working on in this project right now is using a completely different open source MPAO tool to see what kind of results you can get, because you can also incorporate, there's some really cool trajectory studies to be done here. And anyways, there's a lot more that can be done with this project with some more robust tools. And it's an interesting concept. When last time when I presented here, somebody mentioned that working in this person was sort of an expert, had a long career in sustainable aviation, and they said, if you really got a passion for this and you work on this for a long time, you might be able to save the world, which was strong words, but it's a really cool problem to work on because of the motivation behind it. But yeah, hopefully I didn't bore you too much with Python plots. I think they're pretty, but yeah, I'm happy to talk more about those. I'll hang out here until the end. Acknowledgements really, really quickly before I take some questions, but huge thanks again to Ken, and huge thanks to Dr. Spenning for always advising me for these. And last but not least, I also had the help from Dr. Sakar from the department. He has actually also been the advisor for the Human Powerflight research team, and he helped me with these projects. And also, last but not least, Dr. Marty Bradley. I presented in his class. He has a long career in sustainable aviation and was super helpful for this. He actually wrote the request for proposal for this. So yeah, very fun project. Cool, thanks so much. Corny slide to end. If you want to add me on LinkedIn, I do a lot of posts on LinkedIn, and it really helps my ego if I get more likes. So, all right. Thanks so much, and I'm happy to take any questions.
Any questions for our speaker?
I can't wait for the human-powered flight.
Oh, yes!
What are the main challenges? Can you summarize in a minute what the main difficulties are going to be there?
For human-powered flights?
Yeah.
Oh, absolutely, yeah. So, very good question. So we're right now, I'd love to talk about human-powered flight because we're working on a lot. So there's a lot of logistics-oriented stuff. So just for reference, our order scale airplane is 25 feet in wingspan. Our full-scale airplane should be around 110 feet in wingspan. So there's a lot of logistics we are pretty confident we can manufacture those things in-house at USC. It's just a huge problem with storing it and transporting it to the field. And we also have had, so all of these projects at the beginning that I showed, Flugtag was a fun little thing, and the airplane on the right was a 10-foot wingspan, and we already had actually a beautiful example of flutter on that airplane. So we are encountering, completely different regimes. All of us in the team were in the aero design team, so we have experience designing airplanes, but we're finding out that we're in this completely different flight envelope, and we're having all these sorts of aerostructural issues. So I would say definitely the aerostructural part of things. So all of the technical analysis, that's completely different from what we used to do, but also a lot of logistics. Not only in, figuring out where to start this thing, or where to build it and how to transport it, but also just starting a club at USC has been very, very fun, but we've also learned a lot of what to do and what not to do with the process. So.
Any more questions?
Yeah.
Can you tell me more about what Swave does and also what DSO does?
Yeah, absolutely. So happy to talk about it. So.
Sorry, I put more than mouse away.
Oh, no worries. No,
it's okay now. It's okay now.
Yeah, perfect. So so they're both sort of the end goal here is that you have a if you have a tool. Oh, perfect. Thank you. The end goal here is that if you have a tool that can do this, for a single design, so a tool where you give it a bunch of geometry, and information about the geometry and/or propulsion, and it can simulate an airplane over a mission, and you get something like this, like a series of time states. What you can do is you can now change the geometries and change input design parameters to get output performance parameters. So that's generally what you look for in a tool that can simulate an airplane with enough physics, and then from there you optimize. You either, here this is not what I did is not optimization in the sense that I'm brute force varying design variables. But if you have, so if anyone's familiar with OpenMDAO, OpenMDAO is a tool that has a lot of very efficient gradient computations and things, so you can do super nice gradient-based optimization. So that's the idea. One big difference, though, between Swave and the SARA tools is I mentioned the SARA tools integrates the equations of motion. So that is, there are terms for this in dynamic optimization. I believe they're called like explicit shooting and implicit shooting. Explicit shooting being you have an initial condition, and then each next state is dependent on. Whereas implicit shooting is where you define a set of nodes, and then you just solve a bunch of residual equations instead of actually integrating time by time. Swave is the implicit shooting, whereas my tool is the actual the integration. So Swave is a little bit, let me be honest here, is significantly more efficient. My way is a bit of a brute force method, and I've been thinking about why we do this, and I think I finally understood. So I learned a lot about numerical simulation from my colleague who is at the rocketry team, and all their simulations, I'm pretty sure need to be explicit, shooting, because they're running Monte Carlos on varying winds and everything like that. So they're not exactly sure what their trajectory is going to look like. So that's why we do things that way. But yeah, that's generally the idea. Input design parameters. If you can simulate it for a bunch of different geometries, and then know where to move towards, in your design. So. Yeah.
Your presentation had a lot of information to take in. So realistically, how much time are you putting into this project?
Yeah. So good point, and I apologize for that. So I tried to compress this hour-long, 70-slide presentation into somehow 50 slides. Did I do well on time? I don't know.
We're good.
Okay, cool. So yeah, apologies for that. How much time I spent on this? So I haven't been working on this a lot because I've just been busy with the human-powered stuff. I start these designs throughout the spring semester. So I worked on this last spring. I worked on this set of codes over the summer quite a bit, or mostly right after, at the tail end of the summer. And then my presentation with Ken a couple of months ago was December, so I did some work more in November. So I've been mostly on these competitions. Highly recommend people to participate, by the way. Another great offering by the AIAA. They actually open up mid-fall, so you can start working on these designs from very early on in the school year.
All right.
Thank you all so much. Appreciate it. Thanks so much.
Okay, please, 1, 2, 3. 1, 2, 3. Another one. Out. Thanks.
Thank you so much. Thank you.
Yeah, these are the links, right?
It's only 2 of them. So he has more.
Yes, more, yeah. Let's see. That there. Yeah.
Oh, you can go to the third.
Actually,
All right. So our next speaker will be Dr. Nahum Malamed from Aerospace Corp. Ken is gonna bring up a lot of links for his presentation, so we'll get started with that momentarily. And then, as a reminder, if you haven't get a chance yet, there's still more sandwiches for you to grab if you're still hungry, and then some more water bottles, and then if you guys want coffee, it's in the back. You can do so as well.
okay, so
Does it come up?
That's one, the aerospace one, this is water.
Oh, okay. No worries. Let's start from the first one.
Does anybody turn on the phone?
No worries, it's an asteroid that's headed our way. Impact.
1 second, 1 second. What is microphone? Wait. Oh, I see, I see. Ah. Share the computer sound, that should work. Okay. Okay, so we start from the first one. And I'll use your no, sorry, is everyone
Good. Talk in the middle. Talk in the middle.
Oh, yeah.
Okay, we are going to start at 2:35. Give everybody a chance to get another sandwich and stuff. But in the meanwhile, we can talk.
Go ahead.
Yeah, I'm just starting to chat around. So I enjoyed the talks that I had here. They're interesting talks. I do like to hear a little bit more about the concept with the aerosol. I didn't catch all of the details there, so maybe we can chat around after. Very cool project. My wife will love it because she's part of the climate center at the college. She's teaching at Westerday College, part of the climate center, and they would be interested in the kind of thing that you're doing a research on. So. So I'm going to talk about asteroids. When we are going to start, I guess in a couple of minutes, we are going to go down that page here. And we are going to talk about this actual asteroid that is now being discovered and has risen to level 3 at a Torino scale. We are going to check in real time what is going on with this asteroid as we speak. But when the asteroid came up to the news media, I received a text from my daughter that says, "Daddy, have you heard about this asteroid? Now it's your opportunity to save the world." And I was delighted because that's my ambition. But we'll see that the asteroid is defying that, and it's probably going to go out of the risk label very soon. But it's still a very interesting case. Just a little bit about me before we go through all of these pages. So one word about my style of presentation. Before COVID, I used to create PowerPoint presentations and have to have them cleared through our public release process. And that could take weeks and sometimes months. And by the time they were presented, the information is old and it's less relevant than real-time data, which is all taken from the web. Came COVID, and during COVID, everything became virtual, and I switched to basically presenting the material directly from the web pages. It's available for everyone to go and visit those pages, and I built a presentation that would have gone onto a PowerPoint anyways. So why doing that? Today we're going to check live what's going on around our planet as we speak, which I think is a cool thing to do in real time. So, Ken, can I start? Am I good to start now formally?
Yes, I'll start, share the sound because you have.
Okay, so another minute or two. Maybe I'll just share about myself. When I chatted with some of the students here earlier and asked me what got you inspired into space, into asteroids and things like that. And when I was a boy, I grew up in Jerusalem, Israel, as a boy. And in a small neighborhood, I basically was familiar with about 5 or 6 streets around my house. And one day my mom comes to me and says, "Hey, turn on the radio. Someone is landing on the moon." And that completely blew my mind. What? I went outside, looked at the moon, and said, "Somebody is working on that, on the moon." And this instantly expanded my horizons from my local neighborhood into the interplanetary space. I was just a kid. I said, I would like to work in those kind of projects when I grow up. And fortunately, I can say that I made it. I do work in really interesting space projects. My main project is to work on the rocket Artemis, which is designed to launch the next astronauts to the moon. That pays the bills, and it's excited to be on a mission to the moon with humans. Hopefully it will survive the current budget cuts, but let's hold our fingers that it's going to actually go. But at some point, I'm sure that we are going to send some people to the moon, to Mars, and beyond. But my passion is really something different, which is called planetary defense. I'm going to repeat the story that I told earlier to some of the students, in which about 20 years ago, I've been working at the Aerospace Corporation for about 22 years now. And about 20 years ago, I teamed up with one of our scientists working mainly on human-made space debris. These are rockets and satellites that malfunction, or a rocket stage that launches the satellite out into space. And a few minutes after it deploys the satellite, it becomes what we call space junk. And obviously, space junk can cause damage to functioning satellites and stop your GPS and stuff like that. And we're trying to address the concern and find ways to mitigate space debris. But one time, when we were working together on that topic, I saw that he's working on something that looked entirely different and looks kind of cool with some different illustrations. I said, what is that? He said, oh, I'm working on a study that will find a way to deflect an asteroid that is headed into Earth. I said, what? Can I be part of that, please? And he took me in. And initially, it was just a topic of high curiosity and a cool thing to say, I'm working on the deflection of an asteroid. But over the years, I became more educated and more aware of the hazard. And I realized that this kind of hazard, potentially at a very, very low likelihood, can change our society. It has done it in the past. And we believe at the community of planetary defenders, it's a question of when and not if some of these objects might impact with us. So the intent of this talk is to introduce the topic very quickly over about 20 minutes. I already mentioned that I'm happy to come and give a talk at your institutions. You feel free to invite me. I already gave a couple of talks at UCLA a couple of times, and as a result of that, UCLA students came to visit the aerospace to witness the launch of a rocket into space, not to an asteroid. And I'm happy to come to any other of your organizations and give a talk about planetary defense. Usually it's about an hour and a half to 2 hours. So this is going to be very, very abridged version of my talk. Also, one thing that I would mention is that Aerospace Corporation is hiring. If you are interested, if you have American citizenship and you are interested in either summer internship or being considered for a position in aerospace, currently we are hiring. You can approach me, and I'm not the hiring manager, but I'm happy to share your resume with hiring managers for consideration. Now let's go to the main part of my talk. So my name is Nahum Melamed, and I already mentioned this is my intro page that my company put out for myself. You can always go and visit that. Ken can share those web pages with everyone. You're invited to go and visit these pages, where it describes that I work on the Artemis project and with planetary defense. And so let's go to the next tab, please. All right, so here we are going to show a video that shows how big can asteroid get, how large it can get. If you can play this video, please, and make it the maximum size. So when I ask this question at schools, when I give talks at school and I ask the question, how big can asteroids get? Size of a bus, size of a swimming pool, size of maybe a football field. You can see that those asteroids can get much, much bigger. The good part is most of them are stuck in the asteroid belt, which is a belt of asteroids between the planets of Mars and Jupiter. They will never come close to us. They are safe because each one of these would cause mass extinction. That will not happen. But our concern is from the medium size and small ones. That could happen in a lifetime. That's what we are trying to protect from. Let's go to the next tab, please. Okay, and so we are going to go here and check what's going on around our planet right this minute. So if you can slide down a little bit, see if we have, yeah. Okay, so if you can see here, there is distance units in AU. If you click on it and change it to LD, right up here, one more up, a little bit higher, higher, yeah, right there. Oh. And change this from AU to LD. Yeah, that's it. Okay, so now it's measured in lunar distances. It's the distance between us and the moon. Thank you. Which one is the? Okay, so where is it here? Okay, so we are 21st of February, and we can see here that there is an object that is about 10 times distance to the moon, zipping near Earth. Here is one that is actually closer than the moon. The size of this object is between, what is it, 2.7 and 6 meters, something like that. That's a small object. This kind of, this size object is basically going to burn out in the atmosphere. It's going to create a very large fireball, but largely not much of the damage on the ground. And so this is not a concern anyways, and it's not going to come near us. Here's one that is actually closer, and look, now this one, if I can read it correctly, yeah, this one is also a small object, so it's going to burn out in the atmosphere, and so on and so forth. Some of the objects are larger, as you can see here, even up to 200 meters. So all of these objects are zipping by our planet as we speak. They don't make the news because they are not on any risk for impacting with us in the near future. But these are all real objects that could come and impact with us in the future, and maybe not today. How many are there? Let's go to the next tab and see what is our knowledge base. And so as of yesterday, we are aware of almost 40,000, some 37 or 8,000 that are known to us, and the rate of discovery is increasing. We are only aware of about 30% of those medium and small size objects that could impact with us just about any minute. That could take another 2 or 3 decades to reach best knowledge, or at least 95% knowledge of those asteroids. Of course, the good news here is that the real big ones, dotted in the red here, that are about 1 kilometer, an asteroid?
It's an amber alert.
I know. Is this from the library or is it us?
It's us.
Okay. That's me.
Brenda Canceller is missing in danger. Brenda Canceller was last seen on February 21st, 2025 at 0900 hours in Inglewood, Los Angeles.
Let me take down the phone.
Click on the link for additional
I wish I
information.
had an app for asteroids.
It's so convenient to drop an alert and then you while he's talking about asteroids.
That's right.
Oh, actually, it's not an asteroid. The good news is, the good part of the information is that the red curve here that shows objects that are larger than kilometer and can impact our entire planet have been discovered largely. NASA is confident that about 95% of their existing objects have been found. None of them is calculated to impact with our planet in the next century. So we leave it for the next generations to deal. But the small ones, those that are in this kind of regime, have not been discovered largely, and they could impact with us during our lifetime. Maybe a couple of times a century, an object that I'm going to show soon could impact somewhere and cause major damage to a local community. Let's go to the next tab, please. Okay. What does get impact with our planet? We call them fireballs. Fireballs are objects that make it to the ground or make it to the atmosphere. Most of them just burn out in the atmosphere because they're too small to reach the ground. And as you can see here, they are evenly distributed across the planet. No one area is preferred over another. It's just a matter of size of the land, which has the probability of getting impacted by one of those fireballs. Soon we're going to talk about this red one, right, which occurred 12 years ago. And that's the biggest one that is known to date from the category of fireballs. All of that is maintained by JPL, by the Center of Near Earth Object Studies, which is a NASA JPL center in Pasadena. I'm inviting you to go and visit that website. It has wealth of information about asteroids in those pull-down menus here. It's very, very information-rich website. Anybody who is interested in asteroids is invited to visit this website and learn a lot. Let's go to the next tab, please. And now we want to play this video, so if you can start from the beginning.
What exploded over Russia? Presented by Science at NASA. When the sun rose over Russia's Ural Mountains on Friday, February 15th, many residents of nearby Chelyabinsk already knew that a space rock was coming. Later that day, an asteroid named 2012 DA14 would pass by Earth only 17,200 miles above Indonesia. There was no danger of a collision, NASA assured the public. Maybe that's why, when the morning sky lit up with a second sun and a shockwave shattered windows in hundreds of buildings around Chelyabinsk, only a few people picking themselves off the ground figured it out right away. This was not a crashing plane or a rocket attack. It was a meteor strike, the most powerful since the Tunguska event of 1908, says Bill Cook of NASA's Meteoroid Environment Office. In a one-in-a-million coincidence that still has NASA experts shaking their heads, a small asteroid completely unrelated to 2012 DA14 struck Earth only hours before the publicized event. These are rare events, and it is incredible to see them happening on the same day, says Paul Chodas of NASA's Near-Earth Object Program at JPL. Researchers have since pieced together what happened. The most telling information came from a network of infrasound sensors operated by the Comprehensive Test Ban Treaty Organization. Their purpose is to monitor nuclear explosions. Infrasound is a type of very low-frequency sound wave that only elephants, homing pigeons, and a few other animals can hear. It turns out that meteors entering Earth's atmosphere cause ripples of infrasound to spread through the air of our planet. By analyzing infrasound records, it is possible to learn how long a meteor was in the air, which direction it traveled, and how much energy it unleashed. The Russian meteor's infrasound signal was detected by multiple stations, including one in Alaska more than 6,500 kilometers from Chelyabinsk. Western Ontario professor of physics Peter Brown analyzed the data. The asteroid was about 17 meters in diameter and weighed approximately 10,000 metric tons, he reports. It struck Earth's atmosphere at 40,000 miles per hour and broke apart about 12 to 15 miles above Earth's surface. The energy of the resulting explosion exceeded 470 kilotons of TNT. For comparison, the first atomic bombs produced only 15 to 20 kilotons. Based on the trajectory of the fireball, analysts have also plotted its orbit. It originally came from the asteroid belt, about 2.5 times farther from the Sun than Earth, says Cook. Comparing the orbit of the Russian meteor to that of 2012 DA14, NASA orbit analysts have shown that there is no connection between the two. These are independent objects, Cook says. The fact that they reached Earth on the same day, one just a little closer than the other, appears to be a complete coincidence. Infrasound records confirm that the meteor entered the atmosphere at a shallow angle of about 20 degrees and lasted more than 30 seconds before it exploded. The loud report, which was heard and felt for hundreds of miles, marked the beginning of a scientific scavenger hunt. Thousands of fragments of the meteor are now scattered across the Ural countryside, and a small fraction have already been found. Preliminary reports, mainly communicated through the media, suggest that the asteroid was made mostly of stone with a bit of iron. In other words, a typical asteroid from beyond the orbit of Mars, says Cook. There are millions more just like it. And that is something to think about as the cleanup in Chelyabinsk continues. For more news about things coming out of the blue, visit science.nasa.gov.
Thank you. So these are real. 12 years ago, the city of Chelyabinsk experienced that very small asteroid, just 17 or 18 meters. That small asteroid was 20 to 30 times Hiroshima in terms of energy. No radiation, of course, but energy. So very, very destructive. And there's millions of these out there. We know only a small fraction of this. So anybody who is interested in trying to discover those objects, I think I talked to some students there that are interested in finding those asteroids. That is great. We need the next generation of planetary defenders to be engaged with finding them, characterizing them, designing missions to deflect those asteroids or destroy them. We need experts in public engagement. You know, how do we send reliable messages to the public about it without causing panic? Things like this are going to be very top issues if a real asteroid is discovered with a reasonable chance of impacting with our planet. So anybody of you who would like to be engaged, please do. Let's go to the next tab, please. And the question is, can things happen to us here? So here's an example. This is an asteroid that was discovered in 2015. It's called 2015 TB145. It is a 650 meters object, 2,000 feet, one piece of rock that passed about the distance to the moon, slightly passed, at a very high speed, 3 weeks after its discovery, which means that if that object has been aimed at the Earth in 3 weeks, it would have caused continental devastation. That size object would destroy a continent. Think about evacuating North America in 3 weeks, or Europe, or Africa, or Asia. Is this even conceivable? But this is a real object. Here's the radar image of this object that sometimes is being characterized as the Halloween asteroid because it made a close approach on Halloween evening. And it has kind of a shape of a skull, if you can see. So it gained the name of the Halloween asteroid. But it's a real object, very large one, that passed too close to us to feel comfortable. And it happened not to pick us as a target, so we are safe. But it can happen in the future. And there is many more of these that are out there, probably in many, many thousands, hundreds of thousands. So we want to really find them as quickly as we can. And if we detect any of those that might be aimed at the Earth, to do something about it before a disaster can happen, a big global disaster. So it's real, in my opinion. Let's go to the next tab, please. Here's an interesting object that has made the news. This is again a news bulletin from JPL, from the Jet Propulsion Laboratory. As you can see here, an object has been discovered that moves across the fixed stars. This is how they detect asteroids, right? They aim a telescope at the sky, and they try to find a moving dot of light relative to the known map of the sky, just like so. And when they see a new dot that moves across the sky, they try to compare it to their catalog. If it is on the catalog, it has been discovered in the past. But if it's not, and it's a new object, then all of the telescopes and the eyes are now aimed at this object, trying to calculate its orbit to make sure that it doesn't aim at us. And if it does, what can we do about it? Similarly to what we have seen have happened in Chelyabinsk 12 years ago. So that is again a news story that came out of JPL just a couple of weeks ago, or 3 weeks ago. Let's go to the next tab. And JPL maintains what is called a risk table that marks those objects based on the probability of impact with the Earth. This object is currently at level 1 because it has less than a % chance of impact with a planet in the year 2032. As of a couple of days ago, it was at level 3. It was the top of this chart here. So what is typically happens is that when an object is discovered, initially with very few measurements, the region of uncertainty is just too high to determine anything. And so they say the object has a chance of colliding with us because it is inside the uncertainty ellipsoid. As they take more observations, the size of the uncertainty ellipsoid shrinks further and further until one of two things happen. Either the asteroid falls out of the region of uncertainty and the impact probability drops essentially to 0, or it stays inside and it impacts like Chelyabinsk. Chelyabinsk was not discovered because the asteroid came from the direction of the sun, and we are blinded. For anything that comes from the direction of the sun, doesn't matter the size, could be a very large one. We won't be able to see it with any optical telescope. The only way to see it is from space. If we had put a satellite between us and the sun and perhaps look at the illuminated side of those asteroids and give us at least an alert, hey, you have a week to evacuate Los Angeles or something else, right? We don't have it currently, right? We don't have this capability, and so we are really not fully protected from this very low probability but real threat. Most likely with additional observations, that object is going to further drop, trend downwards in the risk table, and most likely would just disappear. That's the current trend. It's going to go away, but it did make the news. There's going to be probably a few more news stories about it in the next week or two before it's going to fade into the past. But it shows that these things are real. If the region of uncertainty had shrunk and continued to include this object, and the probability of impact would have risen above 10%, there are certain processes that would have kicked off in terms of what should we do about it. Should we launch reconnaissance missions? Should we launch deflection missions? And so on and so forth. So, let's move to the next tab, please. To understand how to deal with those threats, we organize international planetary defense conferences every other year. The last conference occurred in Vienna, Austria, at the UN quarters because it likely will involve many nations of the world, and we simulated an asteroid and involved international cooperation and coordination. The next one is going to occur in South Africa, near Cape Town, this May. So I'm going to go there. I'm one of the co-chairs of this conference and helping to organize those conferences. I've been involved with this for 20 years and it's very cool. If you slide down this page a little bit, let's just see what is going to be covered in this conference. All of that is obviously available on the web, and let's look at the topics. It covers everything that is related to planetary defense, any missions in terms of policy, discovery, characterization, any methods for disruption and testing, campaign design. If it happened to impact with the ground, what would be the consequences? And disaster management is part of that. Public education and communication, this is key. We don't want to create panic, unnecessary panic, especially when the information is incomplete. And then decide what to do. What are the thresholds for action? And inaction is also a type of response, right? Doing nothing is also a type of response that somebody has to decide and say, well, we don't know enough about the object. We'll wait until we get more observations. And when we get more observations, there could be the possibility it's too late to do anything. So there is a balance to strike there, whether we should act soon and potentially waste the resources or wait until we have reliable information, and it might be either too expensive or too late to respond to it effectively. This is a very high debatable topic among the planetary, the community of planetary defenders. So this conference gathers about 200 to 300 world experts on planetary defense in one venue to discuss it over 5 days of the conference. It includes students' participation. There is a student competition in which best papers are awarded a monetary award, and the papers are going to be published at a special journal or certainly at the proceedings of the conference. So if any of the students might want to get engaged in the next conference, 2027, we don't know where it's going to be held yet, but it's going to be somewhere around on our globe, around the world. Now it's the time to get engaged. If you want to start some study on what could you do against those asteroids, get educated, study orbital mechanics, study how to build a rocket, look at what the DART mission has done, where it collided with an asteroid just about a couple of years ago. Super fantastic asteroid deflection test. Get involved. We do need the next generation of experts to get involved with that, right? Because we are going to be retired. So we need somebody to get excited about doing something about those asteroids, which could be a real threat. So the next conference is going to be in 2027. Consider writing a paper for this conference and publishing it. I think my suspicion is it's going to be held somewhere in North America, so it might be easier to travel from the US. Let's move to the next tab. All right, so I say that, encouraging the next generation to get involved starts from home. And so me and my son are doing research together. I got him involved, and this is a paper that made it to the journal by me and my son here. And the topic that we chose to cover is we compared planetary defense to known natural disasters. How would we respond to known natural disasters and learn from the response to these when we apply to planetary defense? So again, I invite you to read this paper. I think it was a fascinating study to do and learn about that. I think it's a nice read. From what I read, what I heard from people who read it is that they really very much enjoyed reading the paper because it takes things that are known to us and they extrapolate to the topic of asteroids, which not very many people know about, but they could fall into a similar category. Start from home and from your classmates. Let's go to the next one. And this site doesn't, what was that? What I can do is the following. Can you go on Google and just search for asteroid hunters? Just go to Google, a Google page, just search for the two words, asteroid hunters. Asteroid. Okay, I think it will find it well.
This one?
Yeah. And just play the trailer. I think the right side here, this one here should play about 1.5 minutes trailer.
A single strike could wreck our world. And the only thing that can stop it is science.
It wasn't until a couple hundred years ago we even knew that asteroids existed. Finding asteroids before they find us is critical. We use telescopes to take pictures of the night sky. A moving point of light reveals an asteroid.
We use this radio dish antenna. From the radar echo, we can determine their shape, orbit, and size.
Preventing an asteroid strike requires engineers of every discipline and a lot of teamwork. No idea is too crazy.
IMAX invites you to learn about the science, the technology, and the heroes who are Earth's secret weapons.
Did you recognize the guy in the corner there?
Movie star.
So what happened was that my company asked me to build a class, just an intro class for planetary defense, which I've done. And I talked to experts in company just to introduce them to the topic. And one time, a couple of IMAX producers landed in my class because they wanted to develop a movie about asteroids. And they said, "Can we include your class in our movie, please?" I couldn't say no, obviously, right? And so they came to aerospace for one full day of filming, and they shot a small segment of the movie. It's an IMAX movie. It was shown at the California Science Center for a couple of years. I think about 4 years ago. I don't think it's showing anywhere now, but it tells you, grab every opportunity that comes your way to deal with really interesting topics, right? Don't let them escape. When you see something that is really cool, grab it and do it. I saw several very interesting projects that were described today. Grab the opportunity to get engaged with those projects. And maybe some of you will engage with something that is related to saving our planet from asteroids. I think the next one is, that's it. Yeah, that's the last one. So I'm done. Thank you very much. I hope I was able to inspire you about becoming planetary defenders.
Thank you for your presentation, and here's like your speaking focus.
Thank you. Thank you so much. Cheese. 1, 2, airway. Yeah. Fantastic. Thank you.
Thank you.
Thank you very much.
Thank you. All right, so we're gonna get started with our AIAA career panel. So we'll have a couple panelists up here today. So we have Daniel, who will be joining us, and then Dr. Jeffrey Spedding will be joining, and Lindsay Mitchell, and then.
Hi, may the owner of a green expedition come to the front desk, please? Thank you.
All right, and then I don't know who else is planning to go, but we'll be having a career panel momentarily. So we'll have everything set up with their seats. So yeah, you can take this time to go to the restroom or grab any more sandwiches if you're still hungry. And yeah, we'll start the career panel momentarily.
Yeah, I'm not gonna need a table.
Yeah, we don't need it.
Okay.
It's sort of like this is not the first one, this is
How long is this one? Oh, very long. Specific for this location.
Okay.
So actually, you can have 2 microphones. You got the better one. I think it's long enough, right? Really good.
It ends here. So
Yeah, it should be.
Oh, okay, cool.
Yeah, I got this specific for this event. Because they have 3 microphones. The other one to use wireless because they disappear.
All right.
And the wire, actually is much better.
Information that will help us decide what to do.
So after, after you start, maybe we should close, or you want to keep it on? Keep it on, because the light, do you feel the light is too bright?
As long as not hitting your face, like it's fine, like sit down in the middle.
It's okay because it's up there, so it's okay.
It'll be a problem if we're actually seeing it.
So it seems to be.
As long as you stay sit down and then.
Yeah, that's right. We should play that. Your next event, something great in aerospace. I mean it. You know, like you know, the Sound of Music.
Right.
The show, puppy show.
And the birds and the small planes.
That's right. That's right. We're waiting for you. We're counting on you.
Just to complete this is that they chose that because they could measure it from the air. They could measure it like intensity from the air. They said if we slow it down, you can measure immediately success.
You'll see the period.
You see the period shrink. They measure it. They estimated it to shrink like 10 minutes.
Yeah, that's a good age. I guess something.
It was wrong.
Lazy for all the way.
And you cannot do that before you actually measure the mass. How do you measure the mass of the mass? This is an open question nobody was able to answer. You have an idea how to measure the mass of the asteroid, which is just about total light.
You need water?
I wish I could design something, so you can DWB design or your watercraft. Change the direction. And take an asteroid and maybe compete. You
put it down.
That's why it's not your company. Maybe the CEO, say the CEO.
Yeah. So what about Ganu?
Daniel.
Actually, I mean, you know this, the founder was Jordan.
All right, we're gonna get the career panel started. So the panel will consist of myself, Ian Clavio, and then we have Lindsay Mitchell, Dr. Nahum Malamed, Dr. Jeffrey Spedding, and then Daniel Scalise. All right, so we're about to begin. Well, yes, before we get ahead and answer any of your questions that you may have, we'll start by introducing ourselves briefly and then tell our professions where we're at. Okay. All right. So as you guys know, my name is Ian Clavio. Full time at Northrop Grumman as a structural analyst, where I do static and fatigue analysis for classified aircraft. And then I'm also a part-time graduate student at the USC, where I'm pursuing a dual degree of aerospace engineering and engineering management. My projected graduation date is this May. All right.
Hi, I'm Lindsay Mitchell. I'm with AIAA headquarters based in Northern Virginia. I've worked there for about 5 years, and I'm our director for region, sections, and student branches. So I've worked with a lot of you already over email, and it's great to finally meet you in person. And I just oversee all our student branches and sections, making sure that you guys have what you need to have a successful club on campus. Thank you.
So I'm Nahum, you already know me, right? I'm the planetary defender here. Like I said, I grew up in Israel. I came to the US to do my PhD. I studied at Georgia Tech for my PhD to do something interesting as well. It's called Aero-Assisted Orbital Transfer, in which I studied spacecraft that have aerodynamic properties. And so we could fly them through the atmosphere, shape their orbit, and put them on new orbits using atmospheric forces. That was a cool project. I ended up at the Aerospace Corporation working on Artemis. My PhD was on astrodynamics, so I understand orbits and things like that. I understand spaceflight. I give a lot of talks at the IAA sections and clubs and at meetings. I talk at local libraries. I love to go to schools. My most favorite audience is the 4th and 5th graders because I see their eyes popping out of their face and say, tell me more, tell me more, tell me more. These are the most inspirable students. And so I love to give talks at those grades. So I'm happy to give talks at schools if you have siblings or relatives that they like to have me. When I go there, I bring samples of meteorites and space debris, CubeSats, and things like that for them to touch real objects. Thank you.
Testing 1, 2, 3, 4, 5, 6. Can you hear me? Even without this, probably. Well, hello, my name is Jeff Spedding. I'm a faculty member at USC, and I teach classes in introductory aerodynamics. And so shout out to the USC crowd here. Also the Long Beach crowd who I had a nice chat with. It's very nice to see you all here. You know what imposter syndrome is? I'm kind of getting a little bit of that where you find yourself in a place where you don't think maybe you're qualified to be. And that happens a lot to me in my life because I've made a whole bunch of career choices where I've sort of taken turns from a planned trajectory to, well, something else. You never know where trajectory is going to take you, whether asteroids or with people. And I think because that's happened to me, I've never really had a real job. I just work in academia the whole time. So I teach people about what jobs might be like. And but I can talk about that if you're interested. I can talk about possible career trajectories and their changes and so on. And I think the moral of this story is that even if you feel like you're not qualified at the moment, don't let that stop you from continuing and following your passions. And so our life trajectory is extremely hard to predict. And one thing that we can do is to be educated and to be opportunistic and learn to take up challenges as we see them. That's enough. On to the next one.
Hello, my name is Daniel. I also work at USC, though as a staff member, I'm not faculty. I work at also in the Viterbi School of Engineering in the Aviation Safety and Security program. We're a much smaller program than the academic departments, but we cover topics such as safety management systems, aircraft accident investigation, human factors, that sort of thing. And I have degrees from USC in aerospace engineering and applied psychology. So.
All right, everyone. So if you have any questions that you want to ask to any of us, the microphone's in the front, or we can pass it along. Jim will be at the stage.
I have a question for.
Speak directly.
Hi, I have a question for Ted.
Microphone's not on.
You mentioned that in your talk, you talk about like asteroids, and then in Aerospace Corporation, you do like something with the Artemis program. So I'm wondering if there's like any correlation between these two projects, because I know the Artemis program mainly is to like reach the moon, but like your like main passion is the asteroid defender. So is there like some part of like the Artemis program about the asteroid like defense that we don't know about?
Yeah, it's a good question. I didn't show some of the things that we do because of the time limitation of this talk. We have an ongoing project with NASA JPL for building a simulation program that simulates realistic asteroids, not real ones, but simulated asteroids that are realistic in terms of how to design a deflection mission of an asteroid. And one of the methods that we are using is called high-speed kinetic impact, in which we launch a rocket with a spacecraft and get the spacecraft to collide with the asteroid, deliver momentum to the asteroid, and kind of nudge it off the way. The heavier the rocket, the more push you can give to the asteroid. And one of the rockets that we considered in this app is the SLS, or is the core stage of Artemis, right? There is a big core stage, which is called SLS, Space Launch System. We put it in the app, but that is because I put it in. there is no coupling between the Artemis project and asteroids per se, right? If the project does go forward in the future, then that rocket will be capable of launching missions to asteroids. But right now, it's not in their mandate, not in the near few missions if it survives the next few missions. So no direct correlation, but I kind of connected between them because it's a big heavy rocket that can push big heavy asteroids.
I have a question for. Yeah, I have a question for.
Me? Yes. Yeah.
What led you to your interest in aircraft structures?
Hi. Alright, so what led me to my interest for aircraft structures? So, well, I'll start briefly talking about how I got into aerospace engineering. So, how I started like being amazed with in the field of aerospace engineering is that back in like 2013, well, me and my family went to the Kennedy Space Center in Florida as a vacation trip. There happened to be a rocket launch that day, and we all see the rocket launch flying up, and it's pretty amazing that we get to see it during our trip. And that's what led me to being part of the aerospace engineering field. And during my time in like middle school and high school, I was involved in a couple of projects that related to airplane design. Most likely the Boston glider, when I use it when I compete for Mesa. Are you guys familiar with Mesa? Like the Mesa program? Okay, nice. Okay, so I've done a couple of Boston gliders during my time, and then during high school, we had like I was involved in a lot of engineering classes and clubs that will lead me to my career, and then um, here in college, my college for bachelor's is Cal State Long Beach. I've taken a lot of classes providing about design for engineering, and then some basic aerospace engineering classes that I take. But like for aerospace engineering, as you may know, there's a couple of different fields that you can pursue on. So a couple of subsystems like propulsion, structures, avionics, aerodynamics, and so forth. Um, my interest relating to structures is like I like to like be involved and see the whole body of like of an aircraft or rocket project. So that's what I like learn more about, especially if you're doing it hands on, and that's where I really got my experience when learning more uh, about the structure side. So when I first got introduced to structures, it was actually not part of like one of my engineering classes. It was actually during my rocketry days in beach launch team, where I had or we were tasked to do a fiberglass layup design or fiberglass layup for our rocket skins, and we also do like hands-on layup with our rocket fins that I got at Cal Long Beach, and that was I believe that was during the summertime. So I had a lot of time doing hands-on work and experience regarding about layups, building stuff about the rocket, and also have experience in like structures in general. I happened to learn more about through structures during like my beach launch team days, and also learn a lot more in my engineering classes. Eventually, during Northrop Grumman, I eventually got the role of a stress analyst. It first started off doing stress analysis work for the F-18 program, where I very got my first introduction to a variety of stress analysis topics. So a couple of them are like for bearing analysis, net section analysis for static, and then a couple times recently with bolt bending, pin bending, and then some work around around the aerospace structures. And then I also got like first look of fatigue and durability analysis and crack growth. As a young professional, I'm still learning through like the nitty gritty detail about static and fatigue analysis. But thankfully at Northrop Grumman, I was being trained with a variety of stress analyst leads that I can learn from.
So talking about inspiration, right? My sense was that those USC students that are students of Jeffrey are very much inspired by him from the, the sense of the talk and from the projects that you're doing. He must be an inspiring person to you guys, in terms of what you do here. How to get inspired? I think it's really a magic, right? Because you don't know what happens in the next minute when you see something cool, and I say, shall I grab this opportunity or not? This is the kind of things that just happen. You need to recognize, and you say, that's something I really like to do, and you do that. Let me give you a personal example for myself that is related to asteroids, right? The company in which I work has many social clubs, right? Clubs for books, astronomy club, walking club, skiing club, things like that. One of the clubs that we have is a women's club. So it's designed to encourage women to become more knowledgeable about the kind of things that we do. And one time, one of our experts was invited to give a talk about asteroids at the women's club. And I looked at this and I said, I know I'm not a woman, but I am going to call them. I was the only man in about a room with 40 women listening to this guy about asteroids. That's because I decided asteroid is my calling. And at the end of the talk, when we walked back from one building to another, I said, I really would like to push this forward and become engaged, right? And that's how my involvement with JPL started, and the movie and the conference. It became because I dared not to be shy and go to places where those things actually happen. So I encourage you to not be shy, go get involved with all kinds of things that you feel are your calling, are your passion, could be anything. I had astrodynamics or aerodynamics, and I had astronomy, structures. It doesn't really matter. Find your calling and just go there and embed yourself. As they say, 80% of success is showing up, right? So just show up to those places, talk to the experts, try to create engagement with those that can connect you with things that can push you a step forward and get inspired. Just allow yourself to get inspired. I'm allowing myself to get inspired every day of my life, and I think that's the kind of approach I'm wishing from everybody out here.
Thanks so much for all the panelists. On that note, I think that's a really inspiring story. So a question sort of similar to that, to all the panelists. Have you all had moments in your career where, looking back, you made a change or maybe a career decision that you are very proud of, or that you think was a very positive one? And what would that be? And how do you encourage us to be able to realize that we should make those decisions?
All right, so looking back, if I ever have a career change, is that basically the question that?
Yeah, or any like highlights that you look back and you're very glad you did something about your career.
Okay. Yeah. Looking back, I'll talk about like my college days. So looking back at what I did, how I got to here right now. Like when I was like a high school student, I had inspirations to go to like a prestigious engineering college like MIT. But like as I continue further with my academic studies, obviously MIT didn't accept me for it, but I was fortunate to go to Cal State Long Beach, and it provided a lot of opportunity for me to grow as an engineer. Uh, uh, Being part of like a variety of engineering clubs that Cal State Long Beach had, especially for AIAA, it really opened me up into a variety of opportunities to be familiar and learn more about the aerospace industry. I was fortunate enough to be part of AIAA at the Cal State Long Beach student branch. I was like an officer for 3 years. One first year being the outreach officer, and then the next 2 years being the former chair for the club. And being part of AIAA, you're open to a lot of opportunities to grow, network with many people, and I believe that's what got me into like a full-time job exactly. So especially for Northrop Grumman, where they saw my potential of being involved in a variety of student clubs and projects, and meeting people along the way. The first conversation with Northrop is like actually from a phone call. We're talking about internship experience during the summer, and it went on uphill from here. So it really propelled me into the engineer that I wanted to be and will be in the future.
Yeah, so David, you and I were talking earlier about this, so I'm happy to share with everyone else. So I'm not an engineer. I don't have that background at all. I graduated with a degree in English and journalism in hopes that I would be a journalist one day. And of course, I graduated, got internships out of school, and I ended up writing for a quarterly magazine for a very small nonprofit in Northern Virginia that was focused in geospatial intelligence. And that was a very interesting topic that I had learned about and mapping and all the technology involved. And it really kind of exposed me to this industry. And of course, aerospace fits in nicely with that. And that dream of being a journalist kind of shifted, and it's not a bad thing. And I just encourage you all to kind of keep an open mind after you graduate. You might have a very direct path of this is what I want to do, but when you get involved in, when you get a job after college and you kind of get exposed to different departments or different positions, that might change, and that's okay. So now I'm of course involved in community and membership engagement and more communications now, and I'm totally fine with that. That journalist dream kind of went away, but I'm very happy with where I am, and of course I get to be in a room with some very smart students. You guys amaze me with all the projects that you guys are doing. So I don't know. That was kind of my surprise. With being involved with AIAA and kind of that shift to a more nonprofit association background.
So I know that most of us here are technical people, and Lindsay, you're not, but you can definitely be a planetary defender. Because
your talk was interesting, very interesting.
Thank you. Yeah, that's why I do it. I do it because it's interesting, and I think it's more than interesting. I think it is a responsibility to do something about it. By knowing what could happen, and my kids ask me, "What are you doing about it?" I feel that it's my responsibility to do something about the next generation, right? You guys and my kids and everybody's kids and relatives. Because we have to pass it from generation to generation, the responsibility to do better for our community. And that's what drove me many years ago to be able to tell my kids, I did something for your safety. I think that's something important for everybody to do. What I meant to say is that being part of the organizers of the conference, you've seen that there are many topics there, including technical topics and non-technical topics. So everybody wants to write a paper about how they would design a mission to improve the deflection of the asteroid by a few more percentage and things like that. And I have a new idea, a new concept for that. Most of the papers that are submitted to the conference are technical. The area of public communication is undercovered, is not covered enough. Any area, any effort that would address how do we engage the public with a topic in a reliable way is important, as important for public safety as the deflection itself, right? Because we don't want to create unnecessary panic in case a new object is discovered and tell you next week, go to the moon. That's not reasonable. We want reliable communication to be done, and I feel that you could have a very important role in exactly that by, learning how to communicate to the public in a way that will tell them, don't panic. This is what we are doing. This is a reliable source of information. Don't go to that source, just that source. Things like these are very important. So, in my opinion, everyone can be engaged. It's a total community issue. Anybody can be engaged, not just technical people.
There's still more to go through.
Anybody else want to answer?
Oh, that's right, everyone, sorry.
Everyone.
Yeah, Professor and Daniel, go ahead. Sorry for that.
Sorry, Matthew. I have a couple of choices that I made that I look back on and I think they turned out okay. The first one happened when I was doing a PhD in the aerodynamics of bird flight. And one way or another, an offer came for me to work at USC in a mechanical engineering department on mechanical models of insect wings. And I wasn't quite sure what to do. And one evening I was down at the pub, which is what you do. And so I was in sort of mid-throw like this. And my beer was here. You have to drink beer when you're playing darts. So I was playing darts. And at some point during that game, there was a sort of shift in my mind. And I realized I was going to take the job. And, you know, it's really irrational and illogical, but that's what I did. I'd never heard of USC. I had no idea what I was doing, really. But I came here and I liked it, and that was more than 40 years ago. So I think that worked out okay. And the second choice I made had to do with the possibility of getting married. So at first, arguably, I didn't take my job that seriously. There were many things I was interested in, like improving my surfing and going to Hollywood and things like that, and exploring Los Angeles and California and things like that. And I was very unsure whether I wanted to be an academic, because it was very obvious that academics are weird. And I wasn't really sure that I wanted to be one of those. They were very strange people. But then this at the time girlfriend, who turned into my wife, well, anyway, we got married in the end. I realized, okay, maybe I better be serious about my life trajectory, and I should make some decisions here and learn how to put bread on the table as well as just selfishly enjoying myself. And so I decided, okay, I'll give it a shot. I'll try to be an academic, even though I really wasn't sure if I could do it or if I should do it. But I'll try to put some constraints on it so that I can have a regular life as well. And so the deal I made with myself, and who turned out to be my fiance, was I could come to work arbitrarily early, but then I would leave at 5. And so I would have a family life after that, because, you know, I had to keep this woman who I wanted to be my wife, and so on. And that works out okay also. And I'm a firm believer in the fact that it should be possible to be a dedicated and obsessed even engineer, but at the same time be a human. And so those are two choices I made that I think worked okay.
I think this is called work-life balance, right? I know there's workaholics that work 24/7, and there's people who do nothing for 24/7. We don't want to be any of these. We want to have work-life balance. So at some point, dedicate some time for your life, for your loved ones, for society, for movies, for things like that. Games, whatever it is, but it's called work-life balance. I realized that I may have missed a small point when we talked earlier about the question, is that the personal choices. I didn't describe my personal choices. I want to describe what my personal choice was, and I want to say this is not a recommendation. It's just a personal choice. My personal choice in my career was not to jump from job to job to job like many people do, right? I've seen many of my colleagues, especially young ones like you, come and stay 2 or 3, 4 years, get experience. Oh, cannot get promotion here. I'm going to jump to the next one, get a nice promotion, increase in the salary, and so on and so forth. And they jump, and I assume it works for a lot of them. It's nice, you know, increase in their income and so on and so forth. My approach was different. My approach was to try to stay as long as I can in a job that I like to do, and become the expert there, become the go-to person, become to dig as deep as I can and maybe even lead the group. Today I lead a group of about a dozen people on the Artemis project because I just stayed in my job. I completely entrenched in this project and became the person who people come to ask questions about it. And I say again, it's just a personal choice. Instead of jumping from place to place, my personal preference for stability, sustainability, and it's really everybody's passion and interest, and it's completely legitimate to say that I spent 2 or 3 or 4 years here. There is another opportunity for me to go and learn something new, to jump into a new team, and just a personal choice. My own personal choice was to try to stay longer and become an expert in the specific field that I like to do. One more thing I wanted to say that I didn't say earlier is that we are hiring. And if you are interested in exploring hiring employment opportunities with Aerospace Corporation and you are an American citizen, you can approach me and I will be happy to share your resume with a hiring manager. So we are hiring now. This is a hiring mode. Usually they don't last forever. There's low points and high points. Currently it's a high point. So if you're interested, reach out to me.
I have a couple examples. The first was when I was an undergraduate, my student activity was working part-time at the aviation safety program at USC. It was off campus, so it was a little interesting to get to every few days down at by LAX. But my office is pretty active in another group called the International Society of Air Safety Investigators. It's just a society for aircraft accident investigation, and they do a student paper contest every year that they call the Rudolph Kaputzen Memorial Scholarship, and it's at the time it was 1,000 words, now it's 1,500 words, and the winner, or a few winners every year, get to go to their annual conference every fall, and a few hundred people get to go, usually a few NTSB board members, their colleagues from overseas, the military equivalents, accident investigators from manufacturers, airlines, etc. And so I won that scholarship. I wrote a paper on investigating drone accidents back when that was a new thing. It was a little controversial at the time, but I was ultimately proved out with what I wrote, so I'm happy about that. And I got to meet a ton of people in a few days, and I've kept in touch with most of them, and they're now my colleagues, and I've had a lot of them as students recently. And so, yes, on that point, actually, I'll get back to that point, but the second one was after working my job at the Air Safety program, it became more and more clear that these systems fail because people break them, not because were designed poorly. Or if they were designed poorly, they were designed poorly because people made choices that made them poorly designed. So I realized that this was, of course, as much a psychology problem as an engineering problem. So I decided to apply for graduate school for psychology. I'd already had a master's degree in engineering, so I decided I didn't want to go back to get another bachelor's degree. So I applied for a master's degree in psychology at USC. I think I was the first ever engineer to enroll in that program. I was often not often, but a few times the only man in the class. So that flipped. So that was an interesting experience. And it was really eye-opening. It's really valuable. I use a lot of it in my every day-to-day. And yeah, if you think there's a completely different domain that can help your engineering career, I say go for it. And what I was going to get back to, the reason I found that scholarship is because someone knew that I worked for the program, the air safety program, and said, you should apply for this. They sent me an email. I read the email and I applied for it. So read your emails. You will get opportunities in your emails. I send out opportunities to people in the AME department at USC, people in the Astro department at USC, people in the Industrial Systems Engineering department at USC. Occasionally, I'll get 1 or 2 responses back. Those 1 or 2 responses may win that scholarship, go to this conference, all expenses paid, get to meet all these people. People who don't read those emails don't. So if you have 1,000 unread emails, who knows what's in those unread emails? So go through your email, read them. Thank you.
I wonder if I can bounce this question back to the audience, and I know you have a question, David, if just a moment. Maybe some of you can tell us how you got inspired into what you are doing. I mean, I'd like to understand how you picked aerospace engineering or mechanical engineering as your main topic. Any couple of you want to describe how you got inspired into the kind of profession you're trying to gain?
I can answer. I don't like.
Yeah.
So I guess it's sort of interesting. Early on, I was more inspired by architecture than engineering. I guess it's almost like I just didn't even think about the idea of designing aircraft, spacecraft, something like that. So I was interested in architecture, and then I sort of lost my interest in architecture when I learned that it isn't always the most, I guess, stable job. So I was, okay, maybe engineering. And I was thinking of engineering of buildings. And then I realized, wait, I get to supply engineering for like vehicles. That interested me much more. And that was around the middle of my time in high school. So then after that, I was like, okay, I know what I'm going to shoot for. That's my angle.
Anyone else wants to?
Thank you. The reason why I chose aerospace engineering is because I used to tell my grandmother as a child that I'll build her a helicopter. Because when my and my grandfather too, because both my grandfather and grandmother, they always love to go some places, and they like to the like, my grandfather, he was on a wheelchair, so he needed like some support. But when I told him I'll make a helicopter for you so you can easily go to places wherever you want, and he said, "Oh, okay, cool, thank you." And then this was my dream, this was my life goal. Is, I'm working on that towards designing airplanes. Right now, I'm just studying aerospace engineering, but once I finish studying, I will eventually go into designing aircrafts and future aircraft designs.
Super cool, thank you.
Well, Robinson is going to release a new helicopter design in the next couple of weeks, so you might have an opportunity there.
March 11th.
Yes.
March 11th. Robinson helicopter.
Robinson.
Yeah. Just down the road in Torrance.
Maybe another personal story for my family is that my wife is a biologist and I'm an aerospace engineer. I have two kids, and when my son was in high school, and people ask him, well, what do you want to do when you go to college or something? He was thinking, he said, astrobiology. And we were delighted. Oh, astrobiology, Nothing like that. He decided to go into political science. And he's doing PhD in political science now at Cornell and explains the world away to us, right? I mean, every time we have a question about what's going on, we call our son, can you tell us what's going on? And so he picked completely off, topic area of study, and he managed to get himself into Cornell and full ride there. And my daughter has decided to study sociology of education, which is super important, I think, right? It's part of what we discuss, how do you educate the public and how do you engage the public with things that are so, critical to our society. But, it's not the same as engineering. I told them, if you're going to be hungry, there is always engineering. So I think, David, you had a question, right? That I stopped you.
I was just going to say thank you.
Okay.
I think Matthew has a question. But before we go on that, actually next Friday, right, 28th, we're going to UYS College, right?
Okay. So anybody of you heard about the Parade of the Planets? No? Well, look it up. Turns out that literally now, and in the next week or 10 days or so, all of the 7 planets are going to be visible in the sky just after dusk. And my wife, being a member of the climate center at the college, which is West LA College, has organized a watch event where we're going to invite the public to go and look for telescopes, weather permitting, obviously, to see if we can see those 7 planets, which is literally once in a lifetime, right? Type of an opportunity to see the 7 planets lined up in a parade at just after dusk. So that's what we're going to try to do at the college there. I'm not sure if there is an RSVP. We already got hundreds of RSVPs, so I'm not sure if it's even open yet, but that's the event that's going to occur at the West LA College next Friday, this coming Friday, in a week.
That's really awesome. I got to be sure to see that. I guess my question is, and this is a little bit different than I think most of the questions that have been asked, but I think it's still appropriate. And that is just in the AIAA, what are some good opportunities to reach out to general aviation? Because I know that there's been a bunch of, like we talked a lot about the large government contractors, but I'm really interested in general aviation. I feel like there's a lot of new development happening there. I mean, we're getting the lead out of the piston engine fuel. I think that's pretty cool. Just other things like that. So that's my question.
I can speak to that. I've worked with a lot of GA operators, manufacturers. Well, one, it's not strictly AIAA, but I can tell you that this first week of October, the University Aviation Association, of which USC is a member. I don't know if any of the other schools here are members, but I know USC is. It's hosting their annual conference in Costa Mesa. And pretty sure all of the big GA manufacturers will be down there. Yeah.
No, continue. I was
Okay.
about to say a few words.
Yeah, they'll be down there, and a lot of other universities. Most universities in the UAA are flight schools. So your Embry-Riddle's, North Dakota, Southern Illinois universities, et cetera. But there will be there for aerospace engineering, et cetera. So yes, I would say if you can get away from school for a couple days in October, I would say look at that. Also, there are some GA opportunities here in Southern California area. One that comes to mind is Gulfstream has a couple offices. There's a big one in Van Nuys. They have on the north side of Van Nuys Airport. They have a large MRO maintenance base. They have a smaller office in Long Beach, and then I'd say look at pretty much any big company has a flight department. You know, your Bloomberg, Coca-Cola, Walmart has a really big one. Costco has a really big one. They might have, 3 to 10 airplanes, maybe even 15 airplanes. And they all have, need engineering support at some kind. Maybe they have it in-house, maybe they contract. So, and even beyond that, I was going to say it later, even firms you wouldn't even think of would have hire aerospace engineers, hire them, such as Airline Pilots Association has an entire aerospace engineering team to support their work, which you wouldn't think they do, but they do. So there's a lot of the non-traditional places you can look to find openings that most people won't look at.
Yeah, I was out to mention something, Lindsay, I'll pass it to Lindsay for this, because actually I've been thinking about this for years, because AIAA is a lot of engineer, scientists. How does this general aviation jump into this AIAA community? I did see Gulfstream has a big booth in Ascend or SciTech, but I want to tell you, that's why they said, like Daniel said, you have to look at the email and participate. Honestly speaking, our AIAA has several, I don't say many, but Daniel Raymer, Dr. Daniel Raymer, the conceptual aircraft, he's a pilot, he's an instructor. And then we have his AIAA fellow, and we have another AIAA fellow in Ampere, Dr. Susan Yin. She herself is a pilot, but also an engineer, and she's an instructor. So actually, we have quite several, and actually the USC student branch, the former chair, she actually went to the pilot school, want to become a certified pilot. So it is an interest, but I think for AIAA is kind of mixed. The core is kind of engineering, scientific, but we do have quite several members. They are very high in engineering, but they are also pilot. and even instructor themselves. So it doesn't exclude each other. And there was another speaker from Aerospace Corporation, I forgot the name. He actually owned a Cessna. He's a pilot. We have many members, they are actually pilot. So I think it's highly encouraged. So Lindsay can answer you more about AIAA connection with GA. Thank you.
Yeah, I was just going to say at AIAA, we have something called technical committees. There's about 71, 72 of those, all in different topics within aerospace engineering. But we have some that are focused in aircraft, and those TCs will put out white papers, they'll have events. They all kind of do a variety of things, but that might be a good resource if, again, you're looking for a speaker, you just want to talk with somebody from that TC. I'm happy to help make that connection for you. And a lot of the TCs are starting to actually have students serve as members on their committees. That application period is usually during the fall timeframe, so it's up right now, but look in the September, October timeframe to, if you're interested in volunteering and being a part of that committee.
We have time for like one or two more.
One or two more. Any others have any questions? Oh, sorry.
I can ask a question though.
Okay.
I think, sorry, I didn't get your name at the end.
Daniel.
Oh, I have a question. You said you did your master's in like psychology, so like human factors?
Some human factors, although it's applied psychology at USC. The program at USC is not strictly human factors, although Long Beach State has a program that is much more human factors focused. However, because I work at USC, and staff and employees at USC have their tuition covered. So getting the master's degree at USC was great. So that was a big motivation to get it at USC. But I also learned marketing and a lot of organizational psychology, which has really been helpful. For example, telling students why they should, why their pilot should get sleep, and why they should indeed, work with regulators when the regulators have questions and things like that. So.
So you said, so essentially you have like experience with human factors in aviation. Do you have any experience in like human factors in like the space industry, or like, do you know how that? Yeah.
Less so. I mean, I'm not an astronaut for one. But there are, a lot of similarities, especially with the human-machine interface design. Cockpit design and space capsule design are not that different. A lot of the questions, though, because for the instructors they use, my program uses a lot of contract instructors who aren't faculty at USC, but we do have some flight surgeons, including some who are NASA flight surgeons. And the ones they come up with are towards zero-G, working in zero-G. How do you design an interface that works where you don't have sleep in zero-G, how to design a sleep schedule, and radiation, of course, radiation impacts, and also just stress, being away from your family for 9 months, which if you're a naval aviator is something you're probably used to, but if you're bringing someone in from the Air Force, they're probably not. So there's a lot of considerations there.
Daniel says very interesting. Actually, I'm also with what Lindsay said with the AIAA Technical Committee, with microgravity and space process technical committee. Like Daniel says, zero-G, low-G, and whatever G, what you're thinking about for space and the manufacturing in space. So we also welcome, students and anybody interested in TC, microgravity, I can specifically help. If you're general TC, Lindsay will help you to connect to the TC you like. But I do want to say there's a diverse universe. AIAA here is to provide the door for you. You need to participate and engage. I think you mentioned about Barda space, right? They do a lot of, at least somebody talked, Kelsey Long Beach, you talked about you're going to have a visit there. They actually do a lot of microgravity and hypersonic. So I was very surprised when we were in SciTech. Our former president, Dr. Mark Luis, he was somehow involved with BARDA. So I asked Dr. Luis, hey, you're an expert in hypersonic. What do you have anything to do with BARDA? They do microgravity, biopharmacy. Say because they do the re-entry vehicle is empowered hypersonic vehicle, re-entry vehicle. So it is a mixture of many things. And the other thing about GA, I really want to say the LWA came from the Wright brothers. The one of the organization that merged with LWA is Aviation Club. So the dream of flying, the fun of flying indeed was the driven force. But LWA is very unique in the sense that we are not really a GA club. There are many GA clubs around here. And sometimes we LWA have event, we have pilot from Super Hornet pilot, glider pilot, and we have the FAA safety credit. So if you attend our LWA event, you actually get the credit for FAA safety team. So we try to bring this, continue this, and we have a Virgin Galactic astronaut. He was from UK. Then he said he flew, the Wright Flyer, and he just loved the way, the sense of flying. That's a very pure, the essence, origin of love aerospace, passion for aerospace. But I do kind of feel that for LWA, it's not just a GA club. So you're in the right situation. You study engineering or science, but you love to become pilot. That's no problem. As I said, many of our members, they are pilot, they even own aircraft, and even instructor. So it's really wonderful. We keep that passion. So any other question?
I think we're done here.
Yeah, I think we have Ian will tell you we have a mixer later on. So we kind of have to wrap up. So then I think the panel will probably have to end here. You're welcome to approach each of individual panelists and ask questions. So here, because Lindsay and Dr. Meneman already have the track, so this is for Professor. Ian did a wonderful job leading today. Unfortunately, Luis, yes, let's talk for that. Daniel, and we give it to Daniel. Please also thank Daniel. Unfortunately, our section chair, Luis, he just texted he cannot join the panel, but he will be in the happy hour to join us. So just take a picture. Oh, thank you. Cheese, 1, 2, 3. 1, 2, 3. Thank you. Thank you so much. I'll give you that. Can we skip them?
Hope I can hear me in the back, but for final remarks, as Ken mentioned, we will have a AIAA Young Professional Mixer. It'll be located at the Los Angeles Alley Works in Hawthorne, California. We'll start like around 5:30 p.m. to 8 p.m. But you guys can come in anytime if you're available. Located in the heart of the aerospace community in South Bay, it'll be near SpaceX. It's a great opportunity to network with professionals and hang out. And if you are going to be attending, please be advised that alcoholic beverages will be in the happy hour. Ages under 21 are not encouraged to drink. Feel free to use the QR codes to access our AIAA websites and AIAA Engage and our main AIAA LA website. And then if you want to donate, you can click on the QR code here. So we give a portion of the money so we can provide more great events like this. So yeah, that concludes the main event, and I hope you guys enjoyed being here today. Thank you.
Thank you, Ian is wonderful, doing a great job. But before that, about the happy hour next. As you know, it's right next to SpaceX. The previous we did there, we actually met quite several SpaceX people there. So I'm speaking, if you want to network with SpaceX people, that's a great opportunity. That's why we choose the location there. The second thing is actually we want to recognize a very great member of the section, Dennis. Can you come forward? Dennis actually didn't have a chance to on the panel, but he has something he has to do with family. But Dennis has been supporting the section pretty significantly. Not only became a member for the Cal State Long Beach, UCLA, but they also donated 3D printing rocket and help us connect to local high school. So we have a record recognizing.
Right, thank you.
Thank you. So, we have a really great member with us, with Dennis, Lindsay, Dr. Menemet, Professor, and Daniel, Ian. We have way more, but you have to participate. That's trying to say. So we provide opportunity, but you have to be there. So thank you so much again. So we thank everybody here, and it's really wonderful to have you with us. Thank you. Appreciate it. See you next year, next time. Thank you.
All right, so this concludes our event. There are still sandwiches in the back if you want to grab any and some water. And remember to feel free to stop by the AIAA table over here, a couple others as well, for some AIAA swag. Thank you.
DC have really great items, straight from DC. It's hot and fresh. Please.
Take it, please.
Yeah, take it. The shifter have to take it.
We haven't met. Hi. Thank you. No, you didn't.
But I was the same year as Professor Gilpin.
Okay.
So,
Right.
that vintage. So it's been a while.
Yes. So I sort of recognize your face because I was still teaching at that time. And I've emailed you on a couple of occasions. It's a pleasure to meet you.
Still looking for students to apply for that scholarship, that maximization scholarship. So,
Is that right? Okay.
if anybody's interested in that forensics engineering,
Thank you very much.
we should do more safety.
Yeah, that's right.
The hand. And more. However, with another presentation next year.
Okay.
Actually, kind of talking to Professor. You were supposed to RPO.
They're right next to our lab. So I know some of the characters.
Got it.
That's right.
Yeah. That's always the goal, right?
Okay.
I haven't been in this space.
Thank you.
And RPO did really good.
I actually have a brochure here. Make sure I give it to you.
It RPO's interesting.
Yeah. Okay.
So I'm going out to dinner.
It was a pleasure. Yes, I hope so too.
I mean, it
You
has
could. Yeah. Let's do it with the beer next time.
but
Very interesting going out to Denver.